Well, that's not the right camera, is it? That's better. Right. Oh, I don't know. How is everyone? My things are flickering as well. They change more to 50 Hz because they don't remember that setting. Because why would they? You know, it's not like it needs to know it. Ah, dear. It should all be flicker free now, hopefully. Hopefully. No flicker. No flicker. Right. We should be good. Okay. Wish that setting would stick. I have to set it to 50 Hz every single time. It's a pain. Okay. People criticising my hair. That's not a great start to the stream, is it? There's not much of it left. But yeah, I could probably use another haircut. Anyway. So we got here Adam, Willem, David, Fred, Christian, Joey. How's it going? How's it going, Joey? Oh, I've got notifications pop up on my phone like right now. What's it telling me about? It's not great timing. Nothing, apparently. Okay. Buffering and audio lag. Ah, great. I've been noticing the past few days my internet connection has been really bad, actually. Illuminator, how's it going? Hemp Bear. Yeah, so, oh, Brian as well. Heathkit. Thanks, Joey. Oh, dear. $10 is a bit generous, Joey. You already given me enough. It's not criticising, it's awesome. Awesome. It's not awesome here, for fuck's sake. Heathkit. Well, yes, there's a Heathkit sitting over there. I've got some of the parts for it. Ordered them 2 weeks ago, and they arrived Friday. That's pretty slow. What am I waiting for still? iTube. I'm waiting for the iTube still. I think I've got everything else I need. So I'll probably put in the parts we've got for that. Danish native. 37 degrees C. Bloody hell. I can't tell you what the temperature is right now. My weather station's not woken up yet. The screen's turned off. It's still asleep. No, my internet's all wireless, and I did a whole bunch of upgrades a couple of weeks ago, and it was actually working really well. It actually doubled the speed. It was doing really well. And then a few days ago, the speeds went down by 75%. So I had now got half the speed I had 3 weeks ago. It's not much of an upgrade, is it? So I might have to email them about it and say, hey, what you done? It's working really well, now it's crap. Anyway. So I've been losing a bunch of packets and I've been dropping back the bit rates. I'm still dropping it back. It's still too much. This row I might have to drop at 720p. I might have to drop down to 720. We'll see. I don't know, Joey. I'm not getting rid of my Brimes. You want a Brime, you have to bite yourself, Joey. Not sending my gear anywhere. Oh, right. Anyway, Ian's here as well, once again. Anyway, right. I'm still trying to wake up. Yesterday my sleep pattern was absolutely ruined, and I woke up at like 4 o'clock this morning. It's like, oh, that's not good. So you kid your friend, yeah, no worries, mate. So I'm a bit off from normal. So I'm normally still trying to wake up, and this is really still trying to wake up. Could make for an interesting stream if I break something, couldn't it? Must look for 289. Okay. The 289s, I've seen comments from people on some of my videos about those saying that the boot up time is a pain on them, things like that. And they chew through batteries. So humans are never made to sleep for 8 hours solid. I don't know. I mean, normally, depending on which work shift I'm on, I might only sleep for 4 hours because that's all the time I have. And I tend to go to bed late and get up early. So, when I'm on day shift, I'll be getting like 4, maybe 5 hours sleep if I'm lucky. And when I'm on afternoons, I'll probably get 6 or 7. But that's not enough. I do need 7 consistently, really. That's what I find I need. Anyway, you don't care for that. So, hang on, what's that again? See, like a baby, wake up with 2 hours crying. Stream is cutting every 30 seconds or so for 1 second. Oh, yeah, I'm still dropping frames. Yeah, this is not good, is it? I've been noticing when I'm doing uploading. I'll try and say it again. But noticing when I'm uploading videos, scale it back some more. Like until a few days ago, I was uploading. I was getting 2 megabytes a second, like 1.5 to 2 megabytes a second, which is pretty good for me. All right, that's really good speeds for here, right? And the past few days, I've been getting about 400k a second. So, yeah, not so good. And I drop down the streaming rate some more. Right. But now the computer will catch and drop frames. Oh dear. What time is it there? It's 8 AM, or 10 past 8. Okay. And after the last couple of issues, I've had the stream with the thing not automatically, not switching over there because I'm an idiot and forgetting to change cameras and stuff like that. And Ian commented about a bit of a plugin for the OBS software. So I managed to find that plugin, thanks Ian, and I've got it. So I think I've got it configured so that it'll automatically switch over to the quadrant view. And there you go, just did it then. But unfortunately, it does it based on mouse input. So I was hoping there'd be one which is based on video input, so I can detect whether there's movement inside a video frame. So, that way if I'm sitting here waffling away, it will stay on this camera. But if this camera loses the shot, I'm not in it anymore, and there's no movement, it changes to a different camera, one which it detects movement in. That's what I was kind of hoping for, but it doesn't do that way. It's based on mouse input. So, yeah, it's not quite what I want, but it's better than nothing, I suppose. So as you can see, I've got a 4-way view set up, so it's doing 2 views of the disc. to try and at least catch me when I've messed that up. I was going to use a slightly stronger word then. And I've also got one, so if I put the mouse into the top screen, it automatically goes to the top screen. So that's handy. That'll save me a bit of work. Try and change views around and stuff. Yeah, so it's got a few things there which I'm still trying to tweak and play with, but it's it should at least catch those bits where I'm making a mistake. And yeah, anyway, so the thing is, Ian, this because I'm using an older computer, I can only use an older version of software, mainly because I'm using an older version of my editing software. So my older editing software is from 2011 Premiere. It's a CS 5.5. It's quite old. Because I don't want to pay Adobe a monthly fee to edit videos, thanks. So I using an old version of Premiere, which means I can't update my operating system any newer, which means I can't use a newer version of OBS, which means I can't use a newer version of this plugin, which may support video capture switching. I don't know. So I'm using an old version of the plugin, old version of OBS, old version of Premiere, old version of system software. So yeah. Okay, catch that, Joey. Yeah. The new adapter for your 2012 MacBook Pro. That's oh my god, MagSafe 2, isn't it? 2012's MagSafe 2, I think. Is it? I can't remember. I've tried DaVinci Resolve. And I actually, I don't know, I had trouble getting my head around it. I'm quite comfortable in Premiere. But I mean, maybe I should try it again, but yeah. It was actually quite a good source of MagSafe 2 connectors and MagSafe chargers from AliExpress, which I found from China. And they were good ones. But they come and go. They'll sell some, then they vanish. And then they'll sell some and vanish. Yeah. Going to get shut down by Apple or something, I'm not quite sure. Whether they're falling off the table or something. The workshop. Yeah, the thing is, I'm using a 2010 Mac Pro. So, at the time, it's a massive power horse. By now, I mean, your computer's probably more powerful than mine. Even though this is, this is a 12 core, something like that. Anyway. The thing is, with my computer, I've got lots of cables going into it. I've got, I don't know, probably 8 or 9 USBs going into it, that sort of stuff. Multiple screens, HDMI inputs. Yeah, so I've got a lot going on in this computer, and trying to go to something newer would be hard. You'd never go back, after you've gone to Resolve. Maybe I'll try it again, but I mean, in Premiere, I've got like templates and stuff set up in that now, so I'm just like drop in a template folder of when I'm doing a video. I'll just use the same template every time, and then drop the video content into that. Yeah. Adam, yeah, you need to get a SSD. It makes a world of difference on those things. Yeah. I'm still dropping loads of frames. This is not good. I might have to go down to 720, guys. I don't want to. Yeah, I probably do need to go and look at Resolve again. Okay, well, I've dropped it down some more for the flame rate, but it might be because of the movement. It's trying to create some movement, so it's changing lots of pixels on the screen. It didn't drop any frames in, so hopefully it's alright. Hopefully it stays alright. Yeah, I might look at it again, but because that right now is holding back. I think there may be another program as well that's holding back. I can't think of what it is though. Definitely the editing stuff, right? So that's obviously for me one of the most important programs I use. So that's one of the biggest things holding back. But I think there was something else, which I'm trying to remember what it was, because I would like to use a new operating system. Anyway, we'll play with some electronic stuff soon. Instead of waffling. Once I finish with coffee, tinker with something. We'll get that Heathkit parts replaced. We'll get on that. Yeah, there we go. Switched over again. 720 makes me look more handsome. Then that's a winner, isn't it? Yeah, soft focus. Anyway. You just got the notification. 20 minutes. Well, some of that could be your email delay, though. Sometimes emails aren't quick. Anyway. I'll drop some more frames. Not many, though. I'm not happy with this internet connection. You have to email them and say, hey, what's going on? That's the thing, if I'm streaming at 1080p, at least I can do this kind of quadrant view, and people at least with big monitors, which can expand it, can see fairly well. If I'm doing 720, this quadrant view doesn't work quite so well. Because there's not enough detail there, you know? YouTube did notifications of live streams still. Hold on, I've got a notification on my phone. What's that? Well, Big Clive is live. Apparently. We know that. Okay. So, anyway, that's that. So, I'm trying to remember what I did for this setup now for this thing. It's based on mouse movement. So if I'm not moving the mouse around, it will change to this quadrant view from whatever view I'm on, except the top screen view. So if I'm on the top screen view and I'm not moving the mouse around, it should just sit there. So this should just sit here now. Because I've got the mouse on the top screen, it shouldn't change from that one. But I did something with this. I think if OBS wasn't in the front, or was in the front, it wouldn't switch. I can't remember how I did that now. I've changed a whole bunch of stuff to try and get this thing to work. I need to actually remember how to do it now. Yeah, okay, so that's that. So if I come back down to put Chrome in front, which is what I'm using for the chat, if I leave that in front and put it on here, let's see if this switches over. I just need to remember how this works, so I'll make sure I don't get it wrong. Yeah, YouTube notifications have been unreliable indeed. Because think about how many notifications they're sending out. You know, it's not just one channel; it's hundreds of thousands of channels. That's a lot of emails. So I can understand why I don't like to send a lot of emails. You know, it's a lot of messaging each time someone goes live, whatever. Okay. So that changed over with OBS, even not in the front. I'm pretty sure I had this set up so if OBS was not in the front, it wouldn't change over. Hold on. Where is the setting? I actually don't remember it. Right. Give me a second to try and remember this bloody setting on here. Yeah, I don't know. I've still got to try and figure this thing out. It's a bit frustrating, actually. I'm sure I had rules set up for this. There's no rules there now. Screen region, idle detection. I'll show you what I'm looking at. So this is the settings, right? So it's got all sorts of configuration things. You can change the sequencing around on these, so it gives priorities to different things. And I've currently got idle detection set up, so after 30 seconds it will switch to the four-way view. If it's not on that, now, do I change it to ABS? I thought I had that on ABS. Don't switch of ABS in focus, which is risky because if I leave ABS in focus, then that means it won't switch. I don't remember what I did there. Yeah, let's try and remember what I did. Hold on. I know this isn't thrilling for you guys, but I need to get this right. Yeah, I think that's dangerous if I actually do that. Maybe that's why I left it off, thinking about it. Maybe I will leave that alone. Yeah, I don't know. So I've got the screen region stuff. So screen region is what I'm doing to tell it to switch to the top screen when I'm in a certain dimension. So if it's the top screen, which is above this screen, so therefore it's negative values and stuff like that, to know it's detecting that one. So when it goes into that region, it will switch over to that screen. But it's just set up here, that one. Yeah, I don't know. Anyway, I don't know. It's going to switch regardless. Let's just leave it on that. What the hell? Okay. Right. Chat again. His wife got remote. My wife is currently in Australia visiting her parents. You have two Razer Cairo programs. ABS has issues with two of them. Oh. That's the one that Dave was looking at, wasn't it? And looking at firmware updates and stuff like that because of the focusing and. Yeah, I think the picture quality was nicer, but I'm not sure about the other stuff on them. I mean, these are the C922s. So, if I go back to that view there, those three cameras you can see there are C922s. The top view desk one, which is that one there, I think that one's very slightly out of focus. That's the one I haven't adjusted yet. So I'd like to know to help. Don't know. I'm still dropping some frames. I still drop some. Not as bad as it was before, but I'm still dropping them. So that one there is, I think, very slightly soft at its focal distance. I think they've got the focusing set very slightly wrong on these things from the factory. All of them. I think they're all wrong. It's like the test jig is wrong or something. But I've noticed that the auto-focusing ends up stopping at about the right place when you tweak them a little bit. So I think normally they're stopping just slightly off when the autofocus is working. Anyway. Yeah. So anyway, I got the auto switcher working, so at the very least what will happen is you'll see this bench view, unless I happen to leave the cursor in the top screen, which is where I might, obviously I'll do diagrams and stuff up there, Well, maybe the person that was doing the focus adjustment needed glasses or something. I don't know. Undiagnosed vision issues. Yeah, anyway. So hopefully this quadrant view is okay for people. I'm hoping it is. Hopefully it's not too small. I think it might be too small on small screens. I'm dropping frames. I'm dropping loads of frames. This isn't working. Maybe watching 4 lines. Oh dear. I might have to switch over to 720. Because this isn't doing very well. This internet connection is not lasting. Damn it. I might even try rebooting my modem, to be honest. Maybe it's got upset by something. That will take a while though. That'll take a few minutes, which means the stream will drop. Switching to 720 on do quite quickly, and the stream will recover. We've done that before when we went to 1080p. We found that out. But doing the modem will be problematic. This is. I'm just going to stop, change to 720p, and then come back and just try and get something out of this, so don't go away. Yeah, so on 720 now, we'll see how that goes. I'm still dropping frames. But being at 720 means I can actually lower my bitrate even further than what I could do before on 1080. So I've dropped it down some more. And I'm still dropping frames. This is useless. Okay, I'm going to restart my modem, right? This will take a few minutes. So you're going to kicked off the stream, come back and find it again, right? Don't go away. You might have to refresh your page in a few minutes' time, that sort of stuff. I'm just going to try doing that in case that corrects this problem, alright? Are we back already? We might be, I can't tell. And I'm still dropping loads of frames, that didn't work. Right. Okay, we'll see how we go. I mean... I've dropped 486 frames, so it might have just been as a settling down from starting up again. Okay, that's pretty quick. That's good. Okay, let me just try putting the stream up again. This is frustrating as hell. It really is. Just want to see if that solved it or not. I'm hoping it has. Yeah, okay, nothing yet. Let's go some more. So I'll try and find out where it's going to cut out. Maybe it solved it. If it solved it, I'll go back up to 1080. It hasn't solved it. It's dropping out at about 3000. So yeah, not solved. Damn. Oh, that's annoying. I'm going to get out of my ISP and say, hey, your upgrade has made my setup worse. Thanks. Oh, I don't know. Okay. And it was doing so well too. We've done, what, 4 live streams, is it, at 1080p? Something like that. And it's been working alright. I'm not happy about that. Yeah. Okay. Well, we'll play with something soon. I'll just get this thing. I want it to be stable. There's no point in me doing streaming if I can't get a reliable enough internet connection to be able to do it. Anyway, right. Seems okay at the moment. It's like it's stopped dropping. As long as it stays that way, we're good. Very frustrating. Yeah, okay. Well, we'll play with something. Nicky, alright? How's it going? Set an email, have you? Okay, let's have an email up. Okay. Ooh, look, there's an email from Ian Johnston. Oh yeah, that looks alright. That's quite a nice view actually, Ian. That's covering quite a good area, isn't it? That's very effective, that camera actually. I do like that one. Yeah, I'm pretty sure that those cameras actually have better quality than the C922s. From what I saw of Dave's one, the saturation looks slightly higher. I think it might be slightly oversaturated, but I think they're actually nicer looking cameras. I think the image quality just looks slightly more accurate. But yeah, I just bought a C922 and I was actually looking for another camera. So it's a shame that I've only just bought that one. So I've got 3 of those C922s. And if I'd known about this camera before then, I would have bought one of those other ones instead. Maybe. I mean, the price was right, and this other one is a used camera. Obviously a hangover from the old Zoom times recently. Okay, I'll catch you later. White to smeary, yeah. I mean, there's 922s, and I'm not liking them as much. Yeah. Anyway, I want to realise that when I set this over to the desk view, it's going to switch over automatically. So if I do that view there, and I don't move the mouse, this is going to switch over. I thought I'd done something to allow for this though. I might have to change some settings after all. Just waiting to see if it switches. If it does, I'm going to have to do some kind of setting change to this. Otherwise, you're all going to have to put up with a small view. There we go, it's changed over. See, I want it to not switch if it's on a certain camera view. Let's see if I can figure out how to do that. Let's stick this up here so you can see what I'm doing. Right, so it's doing screen region first, which is this top window. That's the priority. Then it does idle detection after that. So if it's already in this top window, it won't do idle detection because this one overrides it. That's how it's set up. This is the one I was looking at before, staying on the current selected scene when a certain application is selected, which means if I set it so OBS is in front or something else is in front, it won't switch over, which is dangerous because it means I may forget that that's the case and it won't automatically switch when I want it to. Yeah, I'm not quite sure what this bit's actually doing. It doesn't actually explain too well what this top section's for. The bottom one you can figure out. What's this bit doing? That's the thing, I don't actually know what this one's doing. It's got some transition thing here as well, mentioned. So, is that automatic transmission transitions or something? I don't know, they've got transitions over here. So, I don't know what this bit's actually doing. Yeah, I need to kind of sort this out. This is just frustrating. I did play with this for ages before. I mean, the idle detection won't switch. And I could set OBS in here. That'll then do that. But that's risky, like I said. Yeah, no problem, Danish Native. It's been a lot of work. I've done 26 beginner series videos. Hold on, let me have a look. This is going to distract me very slightly. See, I've got to 26 here, right? So I've got 4 left to go up from that one. And I've got... This is my next video series, which I'm already halfway through doing. So I've done 7 videos on that already, which is electronics tools and equipment, basically. Just covering little bits of gear, just to suggest things that people should have when they're doing electronics to get them started. So that's what that one's like. I need to do some more on that. Yeah, and then once I've done those, I'll do a repair series, I suppose. That's the plan. Anyway, I'm not really with it today. I'm asleep. Feel really behind the ball. Okay. This is a Windows thing, right? So this is doing something with Windows. I think I'm going to have to just do this and say if ABS is in the front, it won't switch. I'm not sure if this actually saved it or not. Don't know. Let's try it, shall we? Let's go to that camera there, ABS in the front, and see if it switches. You've fallen asleep at the workbench PC a few times. Yeah, I've been known to fall asleep in the chair in the lounge. I think that's part of getting older, isn't it? It's the old thing. Yeah, so we'll see if this switches over. If I move the mouse, it won't switch, so I need to not touch anything. So hopefully if ABS is in the front, it won't switch now. If that setting took. And then I will just have to remember not to leave ABS in the front. Because if I don't do that, then it's okay. If I want to force it to stay on that scene, I can put ABS in the front. It switched with ABS in the front. That setting didn't take. Yeah, well, I was trying to edit one. That's the thing. I was trying to edit a scene. So see, I didn't actually edit it. So what I'll be finding, this is no edit option. So it looks like you've changed it, but you actually haven't. So if I do that, then edit, and then delete that one, then I've got it. It's the only way to do an edit is to actually add a new one to replace existing, and delete the previous one. But like I said, this is an old version. I'm sure the newer versions are better than this. Anyway, so that's now changed. But it's convenient being able to just move the mouse to the top screen and it just, I'm going to say it, going croaky. So it's convenient being able to put the mouse up to the top screen and have the thing that made it switch over. That's really good. I really like that feature. Means a bit less thought is required. A bit less messing around, it's a bit more streamlined. But I need to get the camera switching the same, so I really want to basically detect that there's no movement on this camera, and if there's movement on that camera, switch to that one. That's really what I want to do. With a priority of different cameras, so I'd like to say go to my DSLR camera first, right? So if that camera's on and running, so like I'm recording a video, switch to that one because that gives you guys the best view. And failing that, I'll do like probably the top screen view, or the top desk view, right? And in failing that, I might do the side desk view, or a combination of both. Maybe might do both cameras. I might even create a new view for it, but I really want to get it so that it doesn't switch unnecessarily as well. Like right now, it's locked onto this scene. So if I left ABS in front like I have right now to make it stay on this scene, if I go over there, it won't switch. And that's what I really want to get sorted out. It's age, it definitely is age. I never used to fall asleep in chairs until I got older. I don't know, 10 years ago probably is when I started happening, I suppose. Running out of energy. Anyway. So I've still dropped some frames, but it's been better. So I think we can get on and do some work now. I think it's been okay. I think it's good enough to do some work now. So we'll do that. Question is, do we use this view? Or that view? Or that view? I mean, can you guys see well enough with this view here? Let me know. If you can see well enough with this view, I'll just leave it on this one. Might be safer. I thought it's going croaky. God. Anyway, right. We shall do this Heathkit. Do some more part replacement on this thing. Get it a bit closer to being done. I need to record video on this as well, actually. full view is dead. You're doing bad. Especially at 720. Depends what I'm doing. Yeah, indeed. Side is best, so you prefer the side view. So you guys reckon that view's better, right? Yeah. Okay, we can do that. You see on a 32-inch screen, okay, yeah, it's the thing, you need to be on a big screen, and plus I'm not on 1080 now, I'm on 720, which makes it much worse. There's also the option of when I've got the recording camera going. Let's get this fired up. And it's on, yeah. No, that's not it. That one there. And it's lost it again. Okay, hold on. Just bear with me, I've got to change the camera. It's lost it. And I can't select it. Why can't I select it? Seriously? Give me a minute. Now I can select it. I'm sure that's right though. What's going on here? Not sure the resolution's right. Yeah, it's not. Should be that one. With that. That's better. Okay. Right, what did I miss in the chat? What's the background noise? It's my NAS running, doing a backup. CCTV recorder with movement detection. Yes, that'd be one way of doing it. It would be. Using security cameras. Can you automate the zoom? Well, my throat's going today. Why's it going? Looks weird. Yeah. Yeah, well, it's... Yeah. Spinning discs of iron, isn't it? Well, it's spinning rust discs or something, isn't it? What they're called. I'm going to try and get it focused. What do you reckon? Let's focus in there somewhere. See my nice messy desk. Don't need all that. So what do you reckon? This one, which you can then see what I'm actually recording, which is what I often do when I'm doing the streams, or that view there. Bear in mind, when I'm recording with the HDMI, that one, I'll often do things like zoom in a bit and get closer to things, so the recorded footage is better, because that's the one I'm actually monitoring. I've got the monitor sitting right there, which has got that picture on screen. So I'm inclined to use that one. My throat's definitely going. The second one. So you mean you prefer that view, the side view? Picture's washed out, yeah it is. The C922 doesn't like too much light. Okay, we'll stick with that in. I've got more lights coming on now. Well, that's a reflection. That's awesome, isn't it? That's exactly what you want. It's a nice big reflection in the middle of the desk. Yeah. No, I'll turn it down. Yes, some slight lighting. Okay. So I need to record video on this anyway. So we shall set this up. But it's going to be hard to do video if I can't bloody talk. So. Those are the parts I want there. Yeah. Thing is, can you guys see the right thing there? Because if I'm working on stuff, I'm looking at the view from the other camera, which is there. Well, I'm pointing at it there. I don't know. Because there might be times when I'm working on something like this, you won't be able to see a thing, all you'll be able to see is this. Let's shift this one a bit. Sure, it's a lot better actually. I'm sure this is a great live stream for you guys. Oh dear. That's probably the best view I'm going to get you guys. Short of using the other camera. I need to read RAM, yeah. Indeed. I don't know. I mean, this is obviously a generalised view, but if I'm looking at this camera now, if I'm actually like looking at something and I'm doing recording, you'd be able to see, you know, what I'm doing when I'm zoomed in. Probably a lot more like that, probably. So, no, I'm going to use this one. I think this one's just better. At least then I know what you guys can see. I just have to make sure that my camera doesn't go to sleep and I don't notice, which is possible. I'll go get myself a drink. I shall be right back. Still some dust in there. Right. I think that gives you a better view. I shall right back soon and give you some drink. And the only convenient drink I've got right now is not beer, cans of V. So, not ideal. Okay. Okay, so what's up with it? Okay, so this is the one we were working on a couple of weeks ago. I've already done some work on it. Some of it I need to repeat because I wasn't happy with it. So we went through and checked all the resistors. So I was going to give you guys a summary of what we did before. So you're basically caught up. And then I shall record video for the next part, which is what all these parts are for. So last time we went through, checked every resistor in the unit, checked the tolerances, found a few which were dodgy, or a couple that are dodgy, which are over here. Was there 3? Yeah, there was 3. Or 2, I can't bloody remember. That's right, to make up that. So in here, so I've got these resistors we replaced in here. Right, so that one there is a 10k, that one right there. That was bad. That was showing 15k. And these two here, which I put in series, these larger ones, that's to make a 22k resistor. So we messed around with that last time, trying to make a 22k resistor because we needed a 20 and a 2 or something we did, I think in the end. And but I wasn't happy with the heat dissipation from these. It's getting really hot. It's what was it? It's getting up to about 100 degrees or something, I think it was. So I was like, no, I don't like that. So I don't like those resistors. I'm going to change those again. We also got this film cap down here. It's got to go. These electrolytics seem absolutely fine, so I'm actually going to leave those alone this time. I'm not going to change them, which is really unusual for me. Then on this side we checked this resistor over here and the other ones around the place. These all checked out okay. Didn't find any other problems with resistors. And then we've got these paper caps up here. These need to go. And that is what's in here, replacement caps. So we're going to replace those caps and replace that cap and replace those resistors again with some higher wattage ones, which I'll be a bit more happy about. These I think are 1 watt resistors. These are 1% resistors, but 1 watt. And I've got a 5% 10k as one of them, so that's actually not as accurate. And this other one over here is also 5%, but 22k. So also not as accurate, but it shouldn't really matter. I may even do some selective measurements and see if I can get the best one. Hey, it's your power, how's it going? Whiskey, no, it's this V, it's nothing too special. Hey, Friday House. So, right, let's record some video. So it's now a couple of weeks later. I've got some more parts. Don't have all the parts I want, but I've got most of them. So we can carry on now and do some more replacements. So I've got some replacement capacitors to replace the film cap over here and the paper caps on the back. I've also got some replacement resistors because although we replaced these resistors over here before, just in there. So although we replaced those already, I'm not happy with them because they're getting too hot. So I'm going to replace them again with some higher wattage ones. And just try and dissipate a bit more heat to keep them cooler. That's the hope anyway. We'll see how that goes. I'm just going to replace those again. I've got a proper 22k this time instead of bodging one with 20 and 22. So the bodging one for 20 and a 2K, and I've also got some new 10Ks as well. So these are 3 watt resistors. The original ones I put in there 1 watt resistors or 2 watt resistors, something like that. I think they might be 1 watts, and they're just not really handling the heat so much. So I'm going to replace those. So we get those done at least. I'm still waiting. For a new eye tube. That's still got to come. I've ordered one from eBay. Hopefully it's okay. That's not arrived yet. I was hoping it would have arrived today because we actually finish it, but I don't have that yet. This particular tube will be a week. And that's a 6E5. I was actually watching a Mr. Carlson video yesterday, and actually he's talking about 6E5 and 6E6, and 6E5 is the more sensitive one. So good to know. Okay. Let's have another look at the chat. Cool, all good, right. Ian, I've still got to send you my phone number. Just in case I do something really dumb again. Right. What should we do first? Do caps first then. Get rid of them. So let's see. What do we want? 0.1 and 0.5. These are the 0.5s. That's 0.1. Okay. And those are for the other side. I'll light this way slightly more, try and get better lighting inside it. Remember what happened last time with I had on this particular camera, and each time I knocked the HDMI cable, OBS would lose the camera. Hope that doesn't happen because that's the one I'm on now. Remember last time he actually stopped and cleaned it up a bit. Put some deoxit in the connector and everything. It seems to be okay since then. Hasn't done it since. So hopefully that's actually solved. Right, so I've got a light more behind me now. That should make it slightly better. Definitely better. Okay. So first thing I'm going to do is replace these 2 paper caps, get those out of the way, because those are the most dangerous parts about this whole unit, is that these could fail and destroy the valve completely or whatever, or some other valve. This one I'm going to replace anyway. I'm not too worried about that, but I don't want to blow one of these other ones up because I don't have spares for them. So I need to get these out. These both go to ground one end, so it's easy. You've got a forward designation as well, which should always go to the lowest side. These replacement caps I'm using here, these are PETs, I think. This one say, yeah, metallized PET. That's what I'm going to replace them with. I don't think they've got a polarity. There's no markings on them anyway, so probably not. I'm not that familiar with this sort of stuff. I don't normally use these caps, so this is a new territory for me as well. Anyway, we'll get these out. I have to remember that the 0.1 goes to this end, and the 0.5 goes to that one in between. So 0.1, 0.5. I can get that back to front. Oh, let's get these things out. I think I can just desolder them and have them fall off. That's what I'm hoping anyway. So 0.1 is the top one. I might need more heat. Maybe a bigger tip. Come on, come out. That's wrapped, isn't it? Of course it's wrapped. That's annoying. Let's try the other one. No, I'm going to cut those. Alright. These ones I can just pull out. I did that last time. Okay, so let's get the 0.5s first, I suppose. So these are 0.5 plus or minus 20%, and also you can't get 0.5s that easily this anymore. So these are 0.47s. So it's fine. It's got this sleeve on here, I might as well use that. Now it goes back onto there. So I can probably even shorten these up and make them a little bit nicer, but I need to keep enough slack in here so you can move this around to get the eye tube in and out. So I probably will keep it quite slack actually. So what I might do is actually attach the other end, poke that through. Poke that through, so there you go, just like that. Now, I'm not sure if I actually do need to have them connected to the chassis or not to try and improve the shielding. That may be an idea, actually. Maybe it doesn't matter, I don't know. I might just leave them hanging out like this. I'll still do that. Let's put some fresh solder on this. So that's that one. So the original cap there, these are, as I started saying anyway, so 0.5 plus or minus 20%, so you go down to 0.4 to 0.6. And 200 volt rated. The other cap is also 200 volt rated. And again 20% tolerance. So the 0.47 is well within the tolerance of that 0.5 with a plus or minus 20%. And these are 250. These are 250 volt rated. And the other ones here are 630 volt rated. It's actually quite a pleasant surprise to have the price on these be a lot cheaper than what I'm used to buying when I'm buying electrolytics. Yeah, that's quite nice. Anyway, get the sleeve off that one. I'll do the same thing. I'll poke it through here, and then I'll connect it up there. So we'll poke through. Not too worried about getting them poked through, but it's just nice to replicate what's there originally. Come on, there's a hole there somewhere. Another one came out of there. No, I'm not going to get that poked through, am I? No, can't find a hole. That's always a problem. There we go, here's a hole. Right. Okay, I'll get the oven done. And my cat is knocking to come in. Come on, baby. Right, check the chat. Hey Ray, how's it going? Let's drink some more. Yeah, my wife's in Australia, so it's not going to help much right now. And she'll be asleep now, I'll expect. Because it must be 6 AM over there. Right. Just catch up with chat and then I'll get back to it. But bench is full of PDVST minis. Hey Ian, did you see that I'm Side guy? He's got a bunch of LM399s which he's had sitting around for a while. Who's going to sell them? I think he had about half a dozen or so of them. I don't know if you're interested. Just going to wait and see for a response. Actually, I was going to do something before I forget, and I'll carry on with the video. Alright, is that done? Oh right, this is lower grade ones. Right, okay. Yeah, I wasn't sure. I know there's a different version. I wasn't sure which one you were using. I didn't actually know which one was better or not as well, so that's fine. Okay. Okay, back to the video. Oh, I touched the wrong thing. I brushed my mouse too high and it went to the other screen. Cool. Right. Let's get this other end attached. Feed this through there. It's funny that 0.1 is bigger than the 0.5. Obviously because of the voltage difference. Really should be using a bigger tip for this. But as usual, I'm too lazy to change it, so it's fine. That's it. Alright, that's those two done. There's enough slack on those, that's right. Leaving those out. Now I'm going to change this one. That's a 0.05. 0.047. Tolerances on that one. That's plus or minus 20% as well. 200 volts. I think I might have to get stock up on these, so there could be some more capacitor videos coming through it. I might get a bunch of these because I don't have these normally. This isn't a capacitor I usually use, so I'm thinking I should actually just get a bunch of different values and have a small stock of them because they were cheap to get. They weren't that expensive. Wish electrolytics were that cheap. Anyway. Right. So now I'm going to replace the 0.05 microfarad here, which is a plus or minus 20%, and it's also a 200 volt rated. So here I've got a 0.047, also might 473, and that's 630 volt rated, this one. So yeah, that's, you know, a bit of an upgrade. So I was going to cut this one out probably. I don't think I'll be able to get that out easily. It's probably wrapped, but I'll find out, I suppose. Hope it's not wrapped. And I can just stick this one across to replace it. And that's the dangerous caps out. Obviously I've still got the electrolytics in here, but I checked them out previously and earlier in the video, and they seemed fine. The size of them is, you know, yeah, it's only, what, 40 microfarad, but the 350 volt rated, and you know, it's pretty chunky. I don't know if I've got anything to even replace them with, actually. If I wanted to replace them, what's this? 100 volt, yes, I've got nothing suitable. So, yeah, I wouldn't bother with that yet. I mean, I've got no reason to replace them. If I needed to, I would get the parts in and do it, but right now they're testing fine. And for me, that's really unusual. Normally, if it's got electrolytic caps in it, and it's a device I'm going to keep, like this will be, then I will replace them regardless. But because of the costs involved in getting these, they're not easy ones to do. Yeah, it's probably not worth it because they're testing fine anyway. There's no signs of them being a problem. They might last another 10 years yet. So in this case, I'm going to leave them alone. If I had any suspicion about them, then I would be changing them regardless, but like I normally would. Anyway, we get to this. Let's chat it again. Price will go up now. Yeah, I should go and get like a whole bunch of different values. I'm not sure what voltages to get though. I mean, 630 volts aren't that big, so I might just get a whole bunch of 630s. But the 200s are definitely nice, or 250 volt, 400 volt versions. They're nice too. So I don't know if I should get a range of voltages and a range of values, or just a range of values. But say it's not something I normally use, but there's been times I thought I probably should use that kind of cap, but I haven't had them, so I haven't done it. So that's where I'm thinking right now, is I should spend, I don't know, $100 or so and get a stock of them. To say they're relatively cheap. Electrolytics, the ones I tend to get, tend to be cheap because they're not small and usually high voltage and stuff like that. So anyway, let's get this out. Right, see if I can desolder a leg and pull it out that way. Whether it's wrapped. It's probably wrapped. Yep, it's wrapped. Let's cut it off. It's not easy to get to that one. Right. Replacement cap. What I was actually quite surprised by is that they didn't actually have any kind of insulation on those legs. I'm also wondering if I should just stick it across the back like that. Or is there a reason it's down here? Maybe it's for noise? It's possible. I might put some insulation on his legs on this thing, just to make sure it's not going to touch anything. There you go, bit of insulation there, bit of heat shrink, nothing too special. Don't know, I'm thinking his legs are really too long. I think I should shorten those up some more. They could be made a lot shorter. I think I'll do that, I'll shorten them down some more. Yeah, I'll do. That's better. Let's put some fresh solder on these, give it a chance to get a decent solder joint. This one's a bit harder to get to. Not quite sure I'm going to get to that one actually. It's not easy. Come on. There we go. Right. Huh. Got an alarm going off. That is my alarm to remind me to upload a video. Doing that every day at the moment. Use a lot of them tend to go for the 630 volt. Okay. So these are metallized PET. Right, so I'm going to come back and just do this one again, because I didn't attach it very well the first time. I was just trying to get it in place. Right, so that's the capacitors done. Now I need to come back and do these resistors again. The funny thing is, I'd be able to come back afterwards and actually test these capacitors with this tester. That'd be pretty cool. Alright. Get the offcuts out of the way. Right, let's get these out. At least I know what I'm dealing with this time, so I know exactly what values I need to put where, so I'm not that worry too much about trying to get in here and do stuff. Hard thing is trying to get the wires desoldered. Come on. I think I poked those through, did I? Can't remember. Come on, off you come. As expected, it's being a pain. I should really push the record button. This usually helps to make a video when you're recording at the same time. Get that side off. Already started desoldering these, but it's not easy to get these apart. There we go, that's that one. That's the 22K. We've got the 10K off. Now, because this is basically a resistor ladder, there's actually a chance that a lot of these resistors will be getting very hot whilst they're being activated. So it depends on the switch position as to which ones are being used. So it might be that if I turn the voltage right up, that a lot more of these will be getting hot. So I don't know. Well, it could just be that it happens to be the ones on the end, because that's what they are the ones that are exposed to most of it, but for their biggest voltage drop. So anyway, I'm going to put new resistors on here, and then we'll be able to power it up again. What I might do is check for accuracy. Come on. Look at that. One count off. Probably all going to be close enough. There goes. There's 3 counts high, that one. 7.5, which is bang on. The first 2 were pretty good. Oh, yeah. Maybe I should do this in a video. What do you reckon? So, because I'm worried about accuracy of these, and I'm fussy like this, and when I replace a piece of gear, if I'm going to replace a piece of gear, I like to make sure it's as accurate as I can get. So the original parts are only 5% rated anyway, but accuracy to me matters. If you're going to put something in there, do it right. So these are 5% rated. So the original parts are 10% rated. So I'm just looking through here to see if I can find one which has got exactly 10k. So I've got some 9.99s, which are closest we've got so far, which are pretty good. And as you can see, because these are 5% tolerant, there is a tolerance there. So I'm just trying to find one which has got the best accuracy to give them the best result in the end when it's installed in the unit. So we've got 3 which are 9.99. I'll just go with one of them. That's fine. We'll use that one. And then I'll do the same thing with a 22k as well. So you can find one which is as accurate as possible. 20.05 is the second one. As close as so far. Come on, get on there. You can see the tolerance is changing all over the place. 20.29, 98. Oh, 21.99, that was really close, that one there. But you see how much they're changing by. So when you're doing something which is a bit more precision, or you want better accuracy, check your resistors. Don't just assume that the value which is marked is what you're going to get. If you want accuracy, select the one you want. There we go. Right. Let's check the chat again. So we'll do the. What I might do is twist the 10K and the 22K together, because they do have a common junction. We'll be honest. So I'm going to record the end of the. I'm going to twist together the end of these resistors because they do have a common junction point. So I'm going to do this because it will mean soldering should be, well, maybe a bit easier, maybe harder, but we'll do that. Give a twist together. We'll solder these up. Then we can try putting them in. Now I shouldn't need to really refresh the solder in the actual unit with the switches, although it is looking a bit dull. I might actually try and clean some of that off actually. Normally I wouldn't worry about it, I'll just put some fresh stuff on, but it's looking a bit dull, so I will actually strip off some of the old stuff. It's obviously not doing quite so well. Try and get in here. I mean, if I really wanted to, I could get my desoldering gun going, but this will be good enough. There's a lot of solder on there. I may regret that decision. Come on, wicking. The wick's not wicking. It's going to make it awkward for me, isn't it? Come on. What I was doing before was working better. I had some flux. It's not really flowing. Come on. Combination of factors here has got the wrong tip on here. I might have to change it at this rate. Oh God. It's dropping nuts, isn't it? Okay, big tip. No, it's still working. Almost got the soldering iron, that's not good. I changed the tip of my soldering iron to get this done because it's not enough thermal mass on the other tip, so it really wasn't working. Whereas now I've changed the tip, it's working much better. So I'm just trying to get the excess solder off and get some of the old stuff off. So I already put more solder on last time I did these replacements, but it's getting excessive and it was looking a bit dull. I wasn't happy with that. That's most of it off. That's good enough. Okay. Let's put some fresh stuff on here. So there's already still a bit there still, but I just want to refresh it. So it wouldn't be way too much solder like it was before. Okay. Should really have my extractor fan going, but it's not going to be too effective up here anyway. Now I must get these the correct way around, otherwise it won't work. Red, red, orange, that's the 22. Brown, black, orange, that's the 10. So what I might do is solder that piece on first, the junction on, then come back and do those two. Should still be able to reach it. The hardest bit is getting into the soldering iron while soldering, holding parts and recording video. Just shorten it down a little bit so it's too long. I'm going to have to kind of lay it down actually like this in order to be able to access it a bit easier. I think that's what I need to do. Yeah, pretty sure. Okay, I'll come back. Right, let's see if I can do it. It's not easy to get in here. Oh, come on. Once attached, I'll do the other ones. I'll come back and re-solder it again afterwards, so I'll get a nice solder joint. That's one on. This is awkward to do. Oh, let's try and get this one soldered. Just there, I've got it kind of bent into place, so hopefully it will attach when I do this. Seems to have done it. So the other thing I'm trying to do now is actually separate the resistors so they're not actually touching each other, just to give them a better thermal area, because if they're touching then it's going to be less heat emanated from them. Obviously heating is the issue I've got here, so I want to get as much heat out of them as I can, so I've got them separated a little bit to try and help that. Let's try and solder this last one on. How does that look? Yeah, not great. I'm happy with that one. Let's do it again. I'll come back when I'm done. Okay. That took a while. So I'm going to find out the camera's been frozen for 10 minutes. Again. Alright, where are we at? Hit the chat. I think we're ready to test this out again. We can test its own capacitors. Get my thermal camera as well. Actually, that reminds me, I need to charge it up. Okay. Discharge electrolytic 3 volts. Clip leads. Okay. Nails are in place. So what I want to do is basically power this thing up and check for hotspots to make sure it's not got any problems, which I haven't detected yet. In case changing something has changed something. Some flux on my desk. Yeah. think it's pretty well charged up anyway. I shall be back very shortly, so I'll quickly do something. Okay, back. Right. Okay. I saw that, Ian. I saw that. Okay. So I've got this parcel placed. Now what I want to do is power this thing up and test it, obviously, and make sure it's actually going to work. Then I also need to check the thermals to see if anything's getting hot. So actually I just need to juggle things around here. So get it plugged in. So AC is currently off, internal. Turn the power on there. Just turn the power on here. Let's just get the thermal camera running first. Get it woken up. Let's stick one of those caps across here. Right, power it up. Spin this around, check for anything going horribly wrong straight away. So far, okay. Same deal here, so far okay. Right. So far, resistors looking alright. Let's try increasing the voltage setting. Nothing really showing up, but the new ones at least. These other ones here looking a bit warm around the outside. But okay, let's check a capacitor with this. So I've got a capacitor already hooked up. One of the ones which I took out of the unit. I might have to turn my lighting down because you can't really see it. So it's going to get grainy. There you can see the eye tube. Yep, you can see it. Great. So, let's count on discharge. Let's put it on bridge. Right, look, leakage. You want to do leakage. Got to set 6 volts. It's a 200 volt cap. Not showing anything. Maybe I should be on another one. Paper mica, maybe I should be on that one. It's a film cap after all, maybe I should do that one. I can see it flicking. That's about it. Nothing sharp as being bad. Okay. That one actually passed. Let's check the paper caps. Just do the, what's that on there? 0.1. No, that's not showing any leakage either. I'm surprised actually. It's 0.5. Volts. No, still looks right too. That's actually really surprising. Right. It's checking on high voltage, see what those resistors are doing. So that resistor is getting pretty warm. It is, isn't it? That's 33k resistor, 84 degrees, and it's right next to a electricity cap. I'm pretty sure it's not a good thing. Those are looking pretty good down here now. 66 degrees, that's far better than it was before. Right, so I was checking the thermals again on here now. It's had a bit of a chance to warm up a little bit. So I've got one resistor up here which is currently 84.7 degrees, which is a 330k, sorry, a 33k resistor, which is going to cross that supply there. The other one's in there actually looking a bit colder than that one. That's like the hottest one, I think. A bit hard to tell. I've still got my lights off so you can see the screen a bit better, otherwise it might be a bit harder to see. And there's the resistors on the back of that switch. I'll try and get the lighting away from that if I can. There you go, 66 degrees. It's like the hottest one on that switch so far. So that's not too bad. It was about 80, I think, 80 to 100 on the very first whistle at 22, which I replaced. So that's handling a lot better. There we go, 70, that's on the 22. So that's doing a lot better now. Happy with that. And the others are looking pretty much alright. Yeah, I think we're fine. Looking good there. It's still doing a leakage test, so I need to make sure I don't touch it. I want to see what voltages, check voltages whilst doing a test. So that's looking okay. Let's get closer. So now I'm going to test voltages whilst it's doing a leakage test to see what it's actually handling the load like. So 150 volts right now, we're getting 151. It's 200 volt caps, so go to 200 first. There you go. It's basically there. So 100 volts, 299. 50 is doing 48. 25 is doing 25.8. 15 is doing 14.4, and these are all close enough to not worry about it really. 10 volts is doing 9.5, 6 is doing 5.5, and 3 is doing 2.9. That's fine. Let's take that cap off. Put some lights back on, get too grainy. Okay, so let's do this without a capacitor connected to it. So 25 volts. Yep, that's what we're getting. Now I can go above 200 volts now because there's no capacitor attached. So 250 is doing 248. 300 is doing 299, 350 is doing 347, 400 is doing 398, 399 even. 450 is that, doing 455, 500, 504, 600 is doing 610. Cool. Excellent. So that's working. Turn power off before I touch something and kill myself live on stream. You don't want that. Well, I say don't want that anyway. So what I think I need to do, so I can charge up my thermal camera, is look at doing a calibration side of it as well. Actually, then I'll be almost done. So I need to replace this bloody tube because it's so dim. Should be able to see that in normal lighting. Anyway, let's come back over here. So you want to see me check the other stuff? Okay. Well, I've changed capacitors now, so it's probably going to need recalibrating. So I need to pull that manual up and do that. It's actually quite easy to do. I did it already. Let me find it. Heathkit. Get that open. Let's find the relevant section of the manual. PDF thing gets really slow when I've got it in the bottom screen. Anyway, there we go, dragged it up there, automatically switched, excellent. So, calibration part. Just got to find that. It'll be after the assembly section, I'm pretty sure. I don't actually remember what page it was on. It's operation. Must be before that, surely. There you go, test the calibration. So I need a 200 ohm, 100k. Is it right? Done the voltage test already, although I didn't have a load on it. But yeah, close enough. Yeah, so I need a 200 ohm resistor to start with. Well, the Magic Eye tube, what it's really doing is showing the current. So as there's more current, the eye closes. So in theory, what you need is a current checking device. That's all you need to do is monitor the current. Okay. We need to follow this procedure to do calibration. And there's two ways of doing it. Did I do this in the last live stream? Or was it after? I can't remember. Maybe I was just recording video at a time. Maybe that's what I was doing. But yeah, I need to do this because I've changed capacitors and stuff. I need to go through the calibration section just to make sure that's okay. It's not that much to it. So bridge calibration, let's read this. I didn't do this one before. Push a knob bushing onto the balance control shaft. Knob bushing? Okay. Is that setting where the pointer is? Yeah. Okay, so that's setting the pointer position. And this is setting up the leakage stuff. So it's possible because of the calibration's wrong, it could be even showing there's no leakage on those caps and there is leakage because it's not calibrated at the moment. Possible, isn't it? So 100k. And it's 1.5 meg, that's the other one I needed. Thought it was more than one. Okay. So let's do this. That might need changing again actually. Oh, maybe I won't do this now. because this might be affected when I change the tube. And I might have to do it again, which means I'll be recording it 2 or 3 times. No, I don't think I will do the calibration now. I think I'll leave it. But it's simple. It's like 100k resistor, adjust the top pot. Then you do a 150 meg resistor and adjust. Is it the bottom one? I think, yeah, bottom one. And then you do a different type of selection, different voltage with the same resistor, and adjust the middle one. It's not as accurate as using a milliamp meter, but that's fine. What's this bit here? So I don't read that bit yet. So I reckon a 25 volt setting might be problematic, really. Okay, I suppose. Should at least try a cap, you reckon? You want to just at least put a cap on it and... Yeah, sure. We can do that. Yeah, we'll do a capacitance measurement, eh? We'll do that. Let's measure its own capacitors. So, let's put this back cover on, to at least reduce the chance of me zapping myself. It's probably a good idea. If I can get it on, that'll be good. Close enough. Need to sit on the top of it, alright? Okay. That will do. Turn it back on. Turn that on, it's on discharge. Okay. So this is a 1 microfarad scale. So that was times 1 by 1 there. So this capacitor should be over here somewhere. Okay, we are. Let's turn some lights off. So hopefully we can see the eye. There we go, you can see it. So without doing a calibration, I'm just going to do a test on, let's do 100 volts, I suppose. And we'll do a capacitance test. I don't know if this is relevant for the capacitance test or not, but it's 200 volt caps, I'm doing it at 50%. And we'll just bring this over here to the bridge mode, and we'll see if this 0.1 microfarad cap does come back as 0.1. It hopefully will. Let's see. So this eye should open up once we get there. We've got this power factor thing here, I've got to figure out how to use that yet, but I think it's over here somewhere. Yeah, it is. Look, there we go. It's very touchy right there, and that's reading just below 0.1. So that actually worked. I don't know if voltage is relevant to that. Let's actually do a measurement, see if there's any voltage changing on that at the same time. No, I'm only getting 2.7 volts across there. So it does that in the low voltage mode. So what this is set to is irrelevant. Okay, so that's all right. Let's check the other one. Considering I haven't calibrated this yet, it's pretty close. It will need recalibrating. I'm going to do that again once I've changed the valve up here, because that might affect the readings. Right, let's do this bridge mode again. So this is a 0.5. There we go. And it is just over 0.5. That's working. The other one here was a 0.05, so that's going to be right at the bottom of the scale here. Not much good for us. So let's get something else. Let's get a, there you go, 100 microfarad. Let's try 100. So this scale is this one. Goes up to 50 on that scale. So times 0.1. Which means I think I should be, well, let's go around about here somewhere, I think. Or the next one over. Oh, it is up there. It's right up there still. Was it just doing it anyway? Where are we? No, it is right at the top there. It's off the scale up top. It's actually 120. Yeah. How do I use this bloody thing? I would have thought that's 0.01. One thing this time around, let's take that off, shouldn't I? Or zap myself. Let me look at this one again. Could be using that wrong. So if that's that one, no, no, yeah, it's definitely 0.05 up here. Okay, so that isn't going to be. There's definitely like a 10 microfarad range. I've already turned it's low voltage, so I'm pretty safe touching it, but still a bit of a risk. Let me try a 10 microfarad. Let's try this one. Oh, I'm on this bloody range here. I should be on that one. That might be it. Try that. So, does 10 open anywhere? No. Yes, up that end. Maybe it just always opens that end. I don't know. Yeah, 10's opening there. On 10. Well, wouldn't it also be over here somewhere? No. Always opens at the end. Okay. Right. Why can't I see that then? Let's do this one again. 120 microfarad. I'm pretty sure I should be over here. But it was up there, so ignore that. Okay, let's find a power factor thing out, see what it does. This is where I should probably read the manual and figure out how to use this thing. Yeah. I don't know. I thought we could measure that. Scale confusing at first, indeed. Usage. What's the bloody scale on this thing? I thought we could do a bigger scale. Lower ranges. What does it say about that? Yeah, it's like it's dividing it down though. Does that mean it's only do up to 50 microfarad? Is that right? Does it say what we can do? I don't actually bloody know. I don't know what the specs are. Capacitance. Should be able to do up to 1000 microfarad. Okay, so I'm reading that. I'm thinking about that correct way around then. eBay's a pain for getting stuff these days, yeah. So yeah, I should be able to do that. I wonder why I can't read those values off it. So I've got an iTube on the way. I bought it on eBay. So hopefully it's okay. It's supposed to be new old stock, but you never know. Yeah, I don't know. So I should be able to measure those caps then. Why can't I? I'm probably doing something stupidly wrong. Don't know. Do I have 1 microfarad standard? I do. I could fish it out, chuck it on there. Let's get my 1 microfarad standard out then. Let's do that. If anything falls over. 20 nanofarad, 1 microfarad. And yes, I know I'm on the wrong screen. I shall fix that shortly. Okay. We want that one there again. It's going to stay grainy, I'm afraid. I wasn't able to see the bloody iTube, will you? Alright, 1 microfarad standard. So that should pop up over here somewhere. There we go. And that is showing, looks like you're pretty close on angle actually. Basically perfectly 1 microfarad. So yeah, it's almost perfect. So yeah, that's fine. So let's try a different range. Could it pop up somewhere else? That's just up there somewhere. I don't think that's relative to that. So this power factor thing here, I'm not quite sure what that's doing. It's like a sensitivity control, is it? Need to figure that out. So maybe that's part of the problem. So 1 microfarad right there is perfect. I'm still wondering why I can't get it to read this capacitor, because I should be able to do it. So that's 100 microfarad. And that particular scale goes up to 50 up here. So if I go down by, that's not 10 times, that's 100 times less. So it should be at the same place, or slightly above it. But I'm not getting it. Only up there, because I think it's just the way it works. It could be the calibration on this particular scale is a problem. Could be calibration's wrong, so the eye's not opening up. I bet that's what it is. Oh, what did I push that for? Yeah, I'm pretty sure that's what it'll be. Because the calibration is too far off, we can't open the eye up. Betcha. So let's do a even bigger cap. So it's supposed to be able to do it to 1,000, isn't it? So let's do a 1,000. I didn't actually buy this for doing capacitance measurements. I bought it for doing leakage testing. That's what I actually wanted it for. So only that's a 10. Go away. So it should be there and somewhere. Again, up the end of the scale. I can see like an overlap in the eye there, which narrows slightly. About there. And also about there, I can see it narrowing somewhere. But yeah, I don't know. Yeah, anyway. That's going to take some playing around with. I think it's just because it needs calibrating. But I think I won't do that until I actually replace that tube, because I think it'll affect it. Right, that's that thing done. I'm happy enough with that. I'll stick it to one side of my desk until I finish doing it, which is that eye tube. We've got to wait for that to turn up. And once that does turn up, I'll be able to finish this video on it. Okay, so what we're going to work on next. Yeah, it's 0.1 microfarad to 50 microfarad scale on the primary range. Then it's got 100 times that. Not 10 times that. It's not a multiplication of 10, multiplication of 100. each time. I think that's what it says anyway. Anyway. Yeah, new tube will look great. It really needs it. That tube is knackered. So I do have a spare tube for my IT12, but it's not the same tube, so I don't want to put that in there in case it blows it up or something. So I'm just going to wait for the new one to turn up, which I've ordered, which will hopefully be okay. That's what I'm hoping for anyway. Yeah, definitely need to get a tube for it. So I'm actually thinking now, because I bought one tube, right? I'm actually thinking I should have bought two, because at the time when I paid for that one, I thought, right, I've got a spare tube. Then I realised, I went and actually looked at it and realised, it's actually not the same tube. I thought I'd be replacing the spare I've already got, and so I still have one spare, but it's a different tube. So it means I won't have a spare tube for this. So if this tube I get works okay, it looks fine, I'll buy another tube from the same guy, and then I'll have a spare. I like to have spare tubes. I'm actually wondering if I should check the other ones as well, see if I need to get other tubes. There's two other tubes in, isn't there? Two? Is it two? Yeah. I should probably get those as well, actually, whilst I can get them. Hopefully I can get them, I don't know. I assume I can. Let me look. Is it? I don't know what page it was on now. Where's the diagram? Here it is. So it uses 6AX4 and 6BN8. I think that's what it says. Yeah, 6BN8. So I ordered a 6E5. So I should get the 6BN8 and the other one as well and get them. Hey Thomas. Yeah, another Heathkit thing to play with. I got it mainly for the leakage testing. I did build mine with a leakage tester. I've got my own one which I built. But Heathkit's cool. And this can also go to high voltage in mine. So yeah, I'll see. I mean, the one I built was using an Arduino Pro Mini, I think it was, and which is what I tend to use for those. And that's measuring a current going into the capacitor with a current display. I've done a project on it. I've shown it on my channel as a DIY project, build your own leakage tester thing, and it does work. But yeah, because it's something I've designed, it's probably not as good as it could be. I'm not really that precise with those things, I suppose. Anyway, so yeah, I need to get some of these other valves. I should look at that. Anyway, so that's that thing. That's all I can do on that now until I get that valve turned up. Once that valve's arrived, then I can sit down, do the calibration on it, and get that all checked, and do the final checks on it and verifications to make sure it's all working as it should. Thomas, most of it's working. In the previous live stream we did, I checked all the resistors. I've replaced a couple of resistors. Hey, look, it's automatically switched. Excellent, it still works. So I replaced some resistors last time. I replaced them again because I wasn't happy with the temperatures running at. They're running too hot for my liking. So I purchased some 3-watt resistors to replace those particular ones with. They're handling a lot better, so I'm happy with that. Replaced the paper caps, replaced the foil cap that was in it. That's what I did today. So all the capacitors are done, apart from the 2 electrolytics, which tested okay last time. So I'm not worried about those. I measured ripple on them last time, and there was basically nothing there. So I was happy with the fact they were actually working okay. And because of the size of them, and I don't have spares to replace them with at the moment, so I thought, well, I'm just going to leave them alone because they seem to be performing okay. Handy mouse, you're heading off, are you? Okay, catch you later, mate. Let's drop away. So that's basically what we've done today, is replace those capacitors, replace those resistors again to higher wattage ones, and just done some verifications to make sure it's kind of working. I did actually, after the last live stream, I did recalibrate it to set the iTube up properly for the current stuff like that. I did actually do that, but now we've replaced some parts again. It's changed all that, so the calibration's off again. So yeah, I need to do that again. But I'm thinking when I replace the iTube, it's going to throw off the calibration. So rather than doing it over and over again, I'm going to wait until I've got that new iTube in there. Then I'll redo that calibration then, and hopefully that'll do the job. Yeah, and then I'll have to figure out how to use it properly. So this, like, it's not a times 10 multiplication. It's got that range switch on there, not the dial, but the range switch. That is a times 100, basically. So it works the opposite of what you expect. So it says times 0.01 rather than times 100. So it's the opposite way around. So it sort of goes against my thinking. So to me, if it said times 100, then you go 100 times what's on the scale. What it actually means is it's times your capacitor value against what's on a scale. So you divide your capacitor value by 100, and then it matches the scale range. So it seems to be the opposite way around from what I would think it would be. So, anyway, but yeah, it seems to be basically working. The leakage is working. Voltages output look pretty close, within a volt or so, most cases. Less than half a volt, most cases. So that's pretty accurate. But yeah, once we get the new iTube, which it really needs, it's so dim, then it'll make a big difference to it, I think. But it may still be an issue somewhere where it's making the iTube really dim. It could be a problem there still, which I haven't detected yet. But once I replace the tube, if it's still dim, I know something else is going on. But I'm pretty sure the tube itself is just ancient. Yeah, the capacitance scale, yeah. So that's what I've been trying to sort of get my head around. But because it's not calibrated, I think that's why I can't see these large cap values, because it's not actually opening up the eye, because the calibration's out. Now I've replaced some more bits. Yeah, have iTubes. No, yeah, no. I purchased one on eBay. I'm waiting for it to arrive. But I'm thinking I should have purchased two. I always like to have a spare. But if this works okay, then I'll get a full set of spares for it. So all these other ones here as well, I'll get those as well to go with it. So the iTubes are 65 in this case. I don't remember what I paid for. Actually, I should have a look. What did I buy that for? Let me look. That's a confirmation. It's from the UK because it's in pounds. Yeah, £23 basically, plus import duties and stuff like that. So, also 50% more, so $45 or, well, listen, how many? $35 to $40 New Zealand, I suppose. So not too bad. Relatively cheap, I suppose. Yeah, well, that's why I want to get spares. So when I do have an issue with this in the future, I can at least be comfortable with that and actually have the spares sorted out. Now, I always like to have spares of things, which are especially with the rare things, hard to find parts. As I've said, there's many videos I've been doing repairs on. I've always said, if you can get the parts now, and it's a thing you can see you wanting to keep for a period of time, get spares. So, yeah, I'll be looking at getting spares for this definitely, most definitely be looking at getting spares for this. So it looks like it's basically working now. It just needs a bit of tweaking here or there, and I'll say calibration on it, get it set up right, get it adjusted correctly. I think it'll be pretty good. The next thing I was thinking, okay, I want to put it on my desk somewhere. That's the next problem, is putting it on my desk somewhere, because I actually like to have it on my desk and actually have it in the videos and have it used. I might take a capacitor out and check for leakage, that sort of stuff. Not just, obviously using an LCR meter or ESR test or whatever, like that peak electronics one that sort of says, yes, well, ESR's good or bad or whatever, or, it's this value, interpret it as you want. That only tells you half a story, doesn't it? It doesn't actually tell you if it's going to start shorting out at high voltage, which is something which is important for a lot of stuff I work on, because sometimes I'm doing with high voltage stuff, so, well, higher voltage stuff's not really high voltage. So, yeah, having been able to test that as well, like it was a capacitor which, as you know, I'll try and string a sentence together. I tend to replace capacitors on site on old gear. I'll just go through and just replace them. And I might test them as I take them out, just to see if there were any problematic ones, to give you an idea of what parts of circuitry could have had problems, purely as a diagnostic tool. But I don't generally only replace if I test bad. That's generally not a great way of doing it, in my opinion. Unless you can thoroughly test a capacitor and go, yeah, that capacitor's definitely okay. Like checking ripple on a power supply rails and think, well, if it's not rippling, probably working alright. That kind of thing. Building up dip IC stock. Yeah. One of the videos I did covered ICs. Did I show them? Yeah, I think I did show some. There's something else. What are my other videos? Oh, one of these electronic tools for beginners series ones which I've recorded. That I've shown some of my collection, I suppose. $4 each for 4008 adders. $4 each. Really? There's some money's been made there. I'm pretty sure I've got a bunch of those. Hold on. 4008. How many have I got? I thought I had a lot more than that. I've got 5. Strange, I'm sure I had a lot more than that. I've only got 5 of those. I might have them stashed in more than one place, that's the thing. Nah, that's it. I must have only have 5 of them. I thought I had about 20 of them. I'll probably use some over the years. Got 40 on the way, got them for 26 pence each. That's more like it. Yeah, 4008s are used in CB qualification stuff and replacements in a few different radios, but mostly things like the Galaxy 949, 959, I think use them as well. But it was originally because of the Cobra 148 and Superstar 360 FM, which had them in the PB010 PCB version. $2 each for dyes? Really? Interesting. Need a tube sponsor. Yeah, tube sponsor, eh? That'd be a thing. Who makes tubes anymore? Does anyone make tubes anymore? I don't know. Got a few tubes and saved a load of ICs from going in a skip a few years ago. Wow. That's horrendous, isn't it? You know? So wasteful. That really annoys me, that sort of stuff. It's like industrial waste like that. It's like, oh, we don't think they're any good, chuck them away. Russians still making tubes? Okay. Stalker 9 FM, yep. McKinley. I don't use a McKinley. I actually own a Stalker 9 FM. I've got one of them. I've got one of those. A heavily modified one from my youth when I used to play with radios a lot. That had a lot of experimentation done on that one. They've got a switch on the back which for use on FM only cranks the power up by quite a bit. It's probably not good for the final. I think I could do, I think it's 20 watts or something. I got out of it. I think I ended up disabling that because I didn't want to blow the final up. Yeah, but it only worked on FM. Obviously, AM SSB just didn't work. Yeah. Anyway. Okay. Guy makes large Nixie tubes. Yeah, wasn't that guy that did? I think I've seen a guy on YouTube doing Nixie stuff. He made a custom tube for Keysight, didn't he? For Daniel Bogdanov. Didn't he do a custom tube for them? Is that what I'm thinking of? I think he did. You got 3 Stalker 9s. Yeah, I've got both versions of Stalker 9. Got both of them. Got the UK version and the non-UK version. Yeah. Definitely. So yeah, that's got me thinking about CB stuff now. Back in the day, when I was a lad, Daddy Bore. His clocks are 3 or 4 grand. Wow. Glass Slinger. Yeah, Glass Slinger sounds familiar. I'm going to have a snack because my stomach's growling now. Breakfast time. One of my patrons, Peter, who's not currently here, I think. He sent me a Nixie tube clock and a whole pack of tubes and stuff like that. Got loaded from ones in there, all Nixie tubes, you know. And he said, "Oh, I'll do something with them one day." So I got this big box of Nixie tube stuff. Very generous of them. And one day I'm going to do something with those. Can I show you? Alright. Let's remember which drawer I put them in. Got them here somewhere. Where have I put them? In one of these drawers. Come on, where are they? Maybe I'll put them out in the other lab. Maybe I'll put them out there because I need the storage space in here. Got them somewhere. That's going to annoy me now. Where are they? I thought they were in here. Here we are. Man, look, they're right in front of me. So it's got 7 IN12Bs, 7 sockets, 7 15Bs, 7 15As, some power board. It's like some kind of kit, which I think he got. I think is a Kickstarter thing. He bought another clock up, something like that. So yeah, that's something I'll do one day. It's on my list of things to do. So that's pretty cool. Anyway, almost finished the bar. Now I can stop properly again. Right. Okay, finished chewing. We can carry on. So yeah, that's pretty cool having that sent to me. That's quite good. Topic suggestion maybe one day. Yeah, Nixon tube stuff looks really cool, doesn't it? It looks really nice. That's a really nice look to them. You know, once you've got some kind of driving circuitry, it's just like a counter driving the clock, then or the display, you can put anything on it. You really can. You could just shove pulses into it and say, "Here you go, display there." But yeah, I'll play with it one day. That's something I do intend to do one day. Is once I run out of other projects, maybe I'll get onto it. I've always got projects, so. Engineers make mistakes. Everyone makes mistakes. You know, everyone makes mistakes. I don't understand why people try and hide the fact they make mistakes. It's just, you know, when I'm doing videos, I might make a mistake, and sometimes I include them, sometimes I don't. But usually, if I don't include it, it's because it just doesn't really fit in the video. It's more of, you know, it's more of the video quality, I suppose, than anything else. Sometimes I chuck them in there, you know, because it's a funny thing or whatever. You know, it sort of fits in, but I don't always put them in. You blow up your spectrum analyzer. Oh yes, that's right. I saw a thing about there's no input diodes. I saw that on the EV blog forum. Yeah. Yeah, that's bad. It's probably blown up that first IC. Yeah, exactly. Don't make mistakes, not do anything. Last night, yeah. Sucks. 3 times married. Yeah, 3 times married. I think that's a clue. You need to learn something there. I don't know. Maybe 3rd time's lucky, eh? I'm on my 2nd wife, so you know I can't really talk too much. I chose better the 2nd time. First choice wasn't as good. I think that's quite common though, isn't it? Anyway, yes. Never good when the magic smoke comes out, indeed. Well, it's good if you're making it. I can't say. It's good if you're making the video at the time. I mean, I've got a few times when I've caught the magic smoke coming out of things and about include that in the video. It's been pretty good for that. My Fluke's still working. Which one? I've got a few Flukes. Not sure which one you mean. I've got so many Fluke things. You need to be more descriptive. The 343A, yeah, that's still going. Although I don't seem to use it much now because I've got the Datron behind me here, so I'm using that as my main reference now. When the 343A, I did a follow-up video on that about a year ago now, wasn't it? I replaced. What did I do on that? Was it the standoffs? I had to make new standoffs for it because they fractured, because they were badly manufactured. Yeah, just watch out on those on the Fluke 343A. You got that big on the left-hand side. You got those big caps in there. Those cans, the tops of those cans, aren't isolated. So when it's powered up, don't touch the top of the capacitor. Don't ask me how I know. Yeah, because they've got like a serious arrangement there. So yes, in mine I ended up having to replace every capacitor in the whole unit in the end. Yours got plastic on them, yeah. I think one of my caps didn't have a plastic cap on it, and I touched it, and I thought, oh, that's interesting. Yeah. Well, what I actually found, even though when I was working on mine, I think I tested the caps and they seemed okay, but I was getting some erratic issues with it, and it did come back to the caps actually not being any good, even though I tested them, they seemed fine. And once I replaced them, it solved the problem I was having, which I think was to do with the current limiting, if I remember rightly. I can't remember exactly too now. It's quite a few years ago I did that. Yeah, but it was affecting something, and it's like as a symptom, and I sort of figured out that those caps are quite important for that part to work reliably, because there's too much ripple coming through, it causes problems. Something like that. I don't remember too well now, but I know that although I checked them, they seemed okay. Once I replaced them, it fixed the problem. I don't know exactly what it was though. No, you fixed can't limit yours because some stolen ideas from my video. Yeah, no worries. That's what it's for. That's why the videos are there, to try and help people out which have the same problem. Yeah. Yeah, there's some interesting things in those. The actual circuit design of 343A is quite interesting the way they've got it done. What I should do is put a diagram up so you guys can see what I'm talking about. How does that sound? Hey, we'll look at that. I think that's a plan. Fluke 343A. 343A. Oh, there's a good one there which I can't show you because it's from Artec manuals. They're funny about their copyrights. I shall go with this one, which is probably okay. Let me see. 98 pages. Where's the diagrams? It's like the last pages. Okay. Yes, they are the last pages. Excellent. Let's try and get this all on screen if I can. So that's the switches. Where the hell was it all? I've forgotten now. Here we go. Right. So that's those big caps, those ones there, those four. And because they're in series with each other, one is negative side, the other side is actually floating half voltage. So if you touch that junction of the caps, you'll get a zap. Don't want that. But yeah, I did find that changing those caps did improve something. Other things I'll do up here, I'll replace some parts in this section. That might be the bit you're thinking of, isn't it? Is it up here? 2 and 304. I think I'll replace both of those, if I remember rightly. The other issue I had in mind was the 300 volt range being glitchy. I'm not sure if I've solved that or not. I think I have. I'll replace some diodes. Where were they? Might have been these. I'm trying to remember now. Which diodes did I replace? Don't bloody remember now. But yeah, one of my voltage ranges was a 300 volt range. And you have 320 volts was playing up. But I could do less than 400 volts on a different range by dropping it down and it would work fine. So it wasn't voltage related, it was range. Something to do with a particular range and the way it worked. It was upsetting it quite a bit, so I don't remember exactly what I did now, I don't remember. Anyway. If I see it's one of its kind, yeah. Ray's got a project of fixing a Tektronix 2710. Not familiar with that. Those cats are expensive, yes. Yes, they are expensive. I couldn't even get the right ones. The ones I used in mine, you probably will see for the videos, they weren't the 3-terminal type, they were, or 4-terminal type even, I can't remember what they were now, 3 or 4 terminal. I had to just use 2-legged radials like normal, and then put some links across the other terminals because some of the paths were actually going through the capacitor, so it goes up one leg, back down another leg, and using that as a routing path, so I had to put some junctions in there. Yeah. Well, that's part of the reason I did the videos, David. So when I was doing stuff, you can go back and review the video. It's like, okay, well, I don't remember exactly what I did, but if I went back and watched the video, I'd know exactly what I did. You know, well, even it's far better than there's notes. Anyway, yes, that's that thing. Let's give it that. So that's part of the reason I started doing the videos is to, well, not only keep notes, but to share the information with other people to help other people resolve the same problems. That comes back to my CB days, you know, doing CB radio stuff where I'd find that I'd see the same fault over and over again. And as a result of that, I thought, you know, sharing the information would probably help other people because the chances are the same faults occur in other kinds of equipment as well, the same repetitive faults. So. Yeah, you do your same, Thomas. Yeah, because it's incredible. You know, I have actually had to go back and look at my own videos sometimes to go and see what I did. I've had to do it. You know, that's exactly why I made them, I suppose. But one of the reasons I made them. You got a valve amp, 2.5 kilovolt. Ooh, yeah, definitely want to give that some respect. Definitely, like you say, touch the wrong thing in that, and you know about it. I've zapped myself a few times when I'm doing new videos. I've done it a few times. Just touch it and just get like a bit of a tingle. It's like, oh, ouch. Move on. Done it a few times. I never actually had a big whack of one because it's my setup here is quite good. You know, I suppose I'm quite well isolated and stuff like that from ground myself in some ways. Unless I'm touching the bench, and that's a bit different. But yeah, I had a few tingles and things. First Rohde worked on 125 kilovolt pulse. Wow. Jeez. Scary. Gotta do some damage. Anyway. So we've got video on that now, but obviously not finished, the IT28. Which is annoying because I actually wanted to do it. I mean, I was actually going to do a live stream last weekend. You may have seen me do a notification for the live stream, and then I end up doing it. I ended up cancelling it because I was hoping to get the parts in time to work on that last week, and they never arrived, so I ended up cancelling it because they weren't here. And so that was a bit disappointing, but I wanted to have that valve and everything done for this time, but I didn't have the valve, so I thought we had enough parts to actually justify streaming and making a video and stuff like that, so that's quite good. Got HP H690B sweep generator. Yeah, so last weekend I was pretty tired. I'd done a lot of stuff and I was just a bit knackered as well, and I thought, well, I don't have the parts I wanted to sit down and do the video I wanted to do and do the stream I wanted to do covering that thing. So I thought, I think I'll can it this time. And so that's why they got cancelled last week. But yeah, so I've got a couple of things to work on. I haven't even powered one of these things up yet. I want to do that actually. I'm really tempted to do it now. Tempted to do it now. It's the Valhalla 2500 EP, which is the transconductance amplifier, which apparently doesn't work properly, which is great. Yeah, I'm tempted to look at it. I haven't powered it up yet at all. I haven't plugged it in. Yeah. Definitely tempted to. I don't know. Should we plug it in, power it up, see if it goes bang? I think we should, eh? I have to record some video doing it as well, though, in case something does go bang. Let's do that. Let's make some room on my desk. Pull this away again. If my soldering on, turn it off. I really wish I had more space up here for shelving. I suppose I probably could put some in actually, but yeah, I need more storage space. I've just got too much stuff. That would be charged up enough. I don't like to fully charge lithium batteries. They're going to be sitting around. So that's probably half charged by now. That'd be good enough for that. those over the back. Did you try to test his capacitors now they're not in circuit? What do you reckon? This one here is really bad for the bloody light reflections, isn't it? Now they're not in circuit, let's retest these with my other tester. Not sure if this works on these or not. It's more for electrolytics. 16.6 ohms ESR apparently. 2.5 ohms. 0.58 microfarad. No, I can't measure that one. I should actually use a proper LCR meter rather than just the ESR tester. I tested those when I did the original teardown. I actually pulled one leg off these and tested them, so those are probably right. This one here was still in circuit, never took that out of circuit. So these tester things about, I know you can't see on screen. So that reckons it's 50 nanofarad, which is right, 50.3 it says. Dissipation 0.001. ESR of 58 ohms. Interesting. At 100 hertz. 1 kilohertz, I'm getting basic same capacitance, about 12 ohms. 10 kilohertz, 49.9 nanofarad, and 3.5 ohms. No, no, can't see that bad. Pry everything up, there we go. But once I've done a calibration on this thing properly, I'll actually retest his caps with itself once it's all done and finished. Be nice to have that in the video, I think. Those vistas there, I'll just throw them away. I would mess around with it. Okay, I've got a little bit of space. Let's see if I can get this on the desk. I need to unplug that. Let's have a look. Just catching up with chat. So what I'm actually doing on here is I've got basically 4 cameras within the same screen. I just got told it to, I just resized them all and position them where I want. Right. Pretty sure I've already changed the voltage over. Pretty sure I remember doing that. Let's make sure. Yes. Okay. Wake the camera up. Okay, change this view. So I'm going to work on this Valhalla Scientific 2500 EP, which I got in the mailbag recently, and apparently it doesn't work properly. Well, that's the theory. So what this does is it converts a voltage into a current, supposedly. So you can input up to 2 volts maximum, DC to 5 kilohertz, works on AC as well, and it will output a current on these terminals here, and you can have a set or range. So remote control, so it's over here. If it switches in this position, it does remote. Or if you bring it around, it will come up to 10 amps maximum. I think that's like 12 amps max in overall, but that's the 10 amp scale. So in theory, I should be able to put this on a small range and hook this up to a multimeter and see what the current is actually going into the multimeter. If the ranging is working correctly. So if I put these on to, say, the 10 amp range of the multimeter, and we should then be able to see if it's going to behave or not when we inject a voltage over here. That's the theory. I might go bang yet. So before I hook it up to anything, I'm just going to turn it on. Should be on standby, which is in this position. Turn the power on. Turn the power on here. Oh, check out that fan. It's like a jet engine starting up. I think that is changing. Okay, LEDs, see if they work. They do. Excellent. Overload isn't showing up. No, it is. Maybe it's not. Maybe it is. Maybe it's not. Maybe it is. Maybe it's not. I guess this costs us nothing across the output. So it's cycling. Okay. Well, I've got to change that fan. Right, let's get a... I don't use one of the nice leads, I want to use some of these other leads. Oh, just trying to find a set I want to use, which can handle the current in case something's horribly wrong with it. I don't use my precision leads for that. I can't put so much current through those. Go on, go in. It's tight. Right. I'm going to put a voltage in this. This may or may not do it. I'm not sure if it can drive enough current. I think in theory it can. It's supposed to be 100k input, so it probably can drive enough current. We'll use this. Then I'm going to create the cardinal sin of having it standing on its end. Alright, so on DC amps, just to start off with, and I'll see if it seems to work or not. based off that. Then I'll maybe change to milliamps if it seems suitable. Right. This is not viewable. No, we'll have to do it by like this. Okay. Right, let's try this. Power it up. What I'm going to do is try powering it from the PDVS2 Mini. I don't know if this can drive enough current or not. I think this can do 25 milliamps, I think. I think that's what it can do. So I just want to try and provide this as a voltage source for this input. Because this is very easily controllable. And then I can just see if the current comes out changes when we're changing the voltage. So I'll turn it on. Output on. Put in 1 volt. Okay. Well, it's doing something. It's doing 7 amps. Even though I'm in the 100 microamp range. 1 amp with 1 milliamp there. 7 amps again. Okay. 10 milliamps. 7 amps again. You see a trend here? Which is why I wanted to start in the amps range on the meter instead of milliamps range. Yep, it's doing exactly the same thing. Every 7 amps. Okay. So if I do remote, does that change anything? No, that's exactly the same as well. Right. For a smaller range, do 100 milliamps. Okay. We've got a difference here now. Now I'm doing 100 milliamps. Oh, sorry, 100 millivolts. We're getting a smaller current. But it's still way more than it should be. So yeah, something's definitely not right. Let's do 10 millivolts, we're getting a negative current. And it seems to have stayed there. Yeah, it's got an offset, negative offset there. Okay. So yeah, definitely not working correctly. And I put it on standby. Yep. Yep, definitely not working correctly. So we've got some interesting symptoms there. It outputs the same current regardless of what range you're on. Very interesting. $20 milliamps max. Okay, thanks, Ian. Do I have schematics? I do have schematics. Let's pull them up. It's actually surprisingly simple. So I'll get the correct one. I've got a few different versions of it. Where's the picture? Come on, give me a picture. There we go, it's the correct one. Right. Because there's actually different versions of this particular unit. So that's the picture of it. I don't know what page it was on. It's bound to be at the end. Okay. So that's basically power supply and control section. bit hard to see there. So we've got main AC input stuff here with the fan just there, which obviously needs replacing, which is obviously a 115 volt fan. That's inconvenient, but that's okay, I can sort that out. I might even have one. So we've got control signals here with the LEDs, LED indicators here. So there's a range switching, LEDs and the relays to control the actual ranges in theory. Got a couple of regulated supplies here. There's layouts. Go back to the top page. No, too far. So we've got a couple of regulators up here as well on this board. And a bunch of electrolytics around the place. So it could even be bad caps which is causing a problem. You never know. It's always a capacitor. So got some op amps down here, or comparators even. 339 comparators. That's the overload indicator, which seemed okay, interestingly. So we've got the inputs over here. We've got some limiting. You've got an op amp here. Gets bigger. Yeah. So that's a zeroing adjustment. There's a zero adjustment on the front panel, which is like a little trimmer, which would be what that is. So it goes through an op amp into another op amp. So this is OP something 103. Not sure what that is. There's an OP07 here, and straight away op amps, right? So you've got an input coming in, op amps. I'm always suspicious about op amps. And so we've got the supply rail smoothing information here. Then we've got these ladders, which is, well, it's not ladders. This is all the output transistors, which are in parallel with a small value resistor there to link them together from the plus and minus 25 volt supply rails. So these are what supplies all the current. So if one of these transistors is bad, it would potentially cause a problem, but we are able to control it. So by changing the input voltage up and down, we were able to actually adjust the current. So it's not like one of these transistors is shorted out, because then you just get a constant leakage current then. So I don't think we've got a bad transistor in this block. These are the pass transistors. You've got two N3055s and two N6246s. So I think whatever the problem is going to be before this block, which basically doesn't leave much. We've got a couple of trimmers in here. There's a trimmer here, trimmer there. A few diodes around the place. I guess that's an operation. Is that? What's that one for? Another indicator there. That's indicator there is. There is actually an LED on the circuit board as well. I actually did have a peek inside it the other day, and there's an LED on the circuit board. So it could be that one there. But yeah, my first port of call would be checking voltages, recapping it regardless, most likely. These are 4.7 microfarad, so easy caps to replace, cheap to replace. There's some more 4.7s here, 4.7 here, 4.7 there, just like you use 4.7s everywhere. So cheap capacitors to replace, there's no reason why you wouldn't do it. Another 4.7 down here. And on the main section, down here again, what do we have? Yeah, nothing really there. So we've got a couple of big ones here. These are massive caps. In this section here, that is 61,000 microfarad caps, two of them, across 25 volt supplies. They're big caps. They're bolted aside to the chassis there. So I opened it up and thought, wow, that's pretty big. Yeah, so it's like basically all the caps around the circuit are just 4.7 microfarad. Almost all of them. The 10 microfarad just here. That actually makes me wonder a little bit if that might be a tantalum, being a 10, in where that is as well. It's like it's helping to balance the circuitry out across each side. So that could be producing noise. I don't know, that might be a tantalum. So it's also a prime suspect, if that is a tantalum. So there's not actually much to go wrong in here. So we've got some Zenas, 4735s, a couple of them. Saw some other ones around the place as well. Some over here. 4735, same Zenas. So my real thoughts are recapping it and verifying these op amps. Yeah, I think there's probably not going to be too much to do. I mean, obviously checking power supply rails, check all the individual rails. So you've got resistors here, it's even bigger. So you've got the plus and minus 50 volt rails here, obviously check those at these points, which obviously then come down to these points, which are then distributed through these resistors here to act as extra filtering and isolation, I suppose. And so you can verify that these voltages on each one look okay, see if one's being loaded down more than the others or something. So you've got lots of options there. There's relay contacts up there, some of them. Oh, get that back. This one. And yeah, just discrete supply rails, like plus and minus 15 volt. So there's 50 volt there, 25 volt here as the main supply for the transistors. Yeah, it's all looking pretty straightforward, really. So I'm thinking, okay, it doesn't work properly. Great. The thing I was really worried about was that it's going to be one of these big pass transistors. You know, there's 2N3055s or 6246s, because if it's those, I might have to replace the entire set. Yeah, that could be fun. Right, chat. Pop the cover, or socket op amp feedback circuit. So here, so it's got some kind of feedback here. 1.5k, 1.5k, so that's divided by 2. And we've got the positive here, which is coming back from this common rail, which is one of the connections. So those are the range selection relays. Now, if one of the relays aren't being changed, you know, it's possible that there's a relay problem and the relays aren't being controlled properly. I didn't notice relay switching, actually. So that's the output control. So from there and here, so the one that goes to the output high, the feedback is coming from the output high terminal. Now that might only be used for the remote section. Where are those going to? Low voltage protection. It's a sensing resistor. Don't know, I'm not sure what's going on there. Let me look again down here, because we've got the manual controls which are energizing relays. Yeah, okay, so that should be energizing relays. But the fact that LEDs are coming on means there is some kind of relay control happening. So that's from a plus 25 VR power supply and 0 volt to turn the LEDs on. And that's plus 24 volt VR up here. So the same power supply is used for the relays as the LEDs on the front panel. So the LEDs are working, so the relays are probably working. I just can't hear them clicking. Yeah, the ranges don't work exactly. So that is why I'm sort of leaning towards a relay problem. Because why would you be getting such a high voltage output or high current output on a low range? So I think that if one of these is welded shut for whatever reason, it could be causing a parallel path which is causing a high current. So we're getting 7 amps with 1 volt input, which isn't even right. But if someone's been tweaking it and trying to turn it down, maybe it's why it's off. So we've got this relay here for the 10 amp range, just here. So no, catch up with chat. Oh, Fred's gone. Catch you later, Fred. These relays are on high current, right? There's only low current side because this is the feedback path. So the fact I can't hear any relays operating means they're probably read relays. Could be. I was there. No, actually, no. I think there was some large relays in there. When I popped the cover off the other day, I did see a bank of relays in it, but there were read relays as well. So I'm not quite sure which ones it's using. The relays are the same as, well, they look very similar to the ones that are in the Fluke 5450A resistance calibrator. Look very similar. I couldn't see them well enough to see if they're the same brand or not. So all that is doing is feeding back into the path for the amplification. So if there's a feedback problem, it could cause excessive current. If there's a op amp problem with either one of these, it will cause an excessive current, which won't be controllable. Because if the feedback is coming back wrong, when we're giving enough of a range change, that means it will ignore range changes if there's an issue with this op amp. Or maybe something in here could be leaking or shorted, which means it will be bypassing that op amp maybe. So you've got a transistor up here. If that transistor there is shorted, would that be doing something? Or this one here, maybe. So we've got a push-pull into these transistors here. So that's push-pull. So I wonder if I could try a different polarity, see if we get a different voltage or a different current. Because we've done a positive current, if we swap the polarity around, it should swap. So positive be one side and negative be the other side. So we should do that. We've tested this side of the circuit out, and that's wrong. So we should test the bottom side of the circuit out as well, shouldn't we? We should do that just to test each half out, because it's mirrored pair. So, what we did before is you put in a positive supply. What I'm going to try to do now is swapping it around, doing a negative supply, and see if we get a negative current out. Because the system is a push-pull system, so it's got a bank of positive referenced pass transistors and a bank of negative referenced pass transistors. You can actually pass an AC signal through it, which means you can actually do positive and negative currents. So if I swap these around and invert it, we should now see a negative current, and we see if it behaves the same way or not. And that may give us a clue about what's going on. So I'll fire that back up again. We'll fire this up. And I should really push record and say all that again. Professional YouTuber. No. Alright. So, when I looked at this previously, we had a positive power supply coming through, and we're looking for a positive current. Because this is a push-pull system, and also handles AC, there's two banks of transistors. One is a positive reference, one's a negative reference transistor bank for the pass transistors, which generates the current. So if I invert the input voltage, do the same test again, we can check the other half of the transistors. All we've actually checked so far is half of the transistors. If we swap it around, we should be able to check the negative side and see if those are working. So we'll power this up, and we'll see if we get much difference. I'm going to put in 1 volt again. Now I need to put that onto DC. There we go. See that? We're getting negative 7 amps this time. So previously we got positive 7 amps. So therefore that fault is common to both the positive side and the negative side of the transistors. Exactly the same. Again, doesn't matter what range you're on. There is some change there. There is some influence from that. It's not being completely ignored. So between 100 microamps, you're getting 8 amps. Do 10 amps, you get 9 amps. So that's 9.3. So yes, there's definitely something going on here. But it's common to both paths, the positive and negative supply, which means it's something most likely before that point. I think we're going to have to open it up, hey? We're going to have to think of this today. We're going to have to. Yeah, let's try and get the cover right off, I suppose. So I can get it right off. There's not really much to see at the back here. You've got the pass transistors here. And the actual brains of it are down here, which means they're easy to get to. So I've slid the cover back just so you can have a look at it and actually see what it looks like inside. I'm going to slide this all back again and bring this forward once I turn it back on again. But the brains of it are actually down here. This is where the actual conversation circuitry is and the control circuitry is. It's right there. This is the pass transistors. There's a fan mounted on the back of this heatsink here. These are two separate heatsinks. There's actually a very small gap in between them. There's not much of a gap, but there is a small gap between those heatsinks. And this side is the 2N6246s, and this side is the 2N3055s. And so that's the push-pull arrangement. That's the push. That's the positive side. That's the negative side. So, as we saw, an equal amount of error, or roughly equal amount of error. I'm pretty sure the pass transistor side is actually okay. Something before that. So I'm going to actually slide this forward again, and we're going to ignore this section, and we're going to look at the front section here. There's also transistors on the bottom edge of the circuit board here, down the bottom. There's actually top and bottom. There's 6 on each side. Lots of transistors. And that's those 2 massive caps I was mentioning before, I think. 61,000 microfarad. Let's get myself some better leads. Okay, so what do we want to check for? Let's get my head around that before I start probing around. In fact, I can hear my water pumps is playing up. I need to go and sort that out. £80 each, those capacitors, you're kidding me. Everyone's really pointing at IC4, swapping IC4 out. It's an IP07. I don't have an IP07. Let me go and sort my water pump out. I can hear my pumps running dry. Be back in a minute. Okay, I'm back. Is that sorted out? It's got a float switch on it, and the float keeps on touching the sides and getting stuck. Right. Let's check the chat before I sit down and do this again. Dozens of OP07s. I haven't got any. Yeah, I'll check that's voltage reference to what though. I need to figure out what supply I need to reference to. Probably either one of those really, wouldn't it? Probably shouldn't matter. This IC3 is an interesting one, I'm not quite sure what that is. So the switch to actually turn the output on and off I wonder if I can do these tests without the output being enabled. Standby and operate switch is there. So that is doing what exactly? That's just showing you a resistor. What the hell is that actually doing? That doesn't make sense to me. Just want to see if I can actually do these tests without the output being turned on. Well, I suppose I just probe around, see what voltages we can find, stuff like that. Power supply distribution. So the IC5, it's got plus and minus supply rails going to it. So IC3 and 4 is pin 7 and pin 4 power supply rails. So we'll check those power supply rails, make sure they look kind of okay, and then we'll look at the inputs. Puzzled about the operation, if I can actually do that without being powered or not, or without being enabled. Anyway, we'll try it. The output's giving feedback, is it? Okay. Yeah. Where's the 0 volt reference? It's got one here somewhere. No, referenced. Maybe I have to pick a ground point somewhere, it might work. Right, we'll try it. Operate switch. Oh yeah, there we go. Yes. Good spotting. It's over here. So yeah, if it has to be in operate mode, otherwise the input isn't actually being passed through. It basically shunts it off. So you have to be in operate mode in order for to get the voltage to come in. Okay. Right. So yes, we'd have to be in operate mode. Okay. So IC4, pin 4 and pin 7 are two I need to check for the plus and minus supply rails. And these caps are ground reference, so that's the chassis. So I should be able to get the chassis connection off the ground. But as a 0 volt rail, I think that will work. Because both caps here are going to the chassis. So it must be using that as a reference. I can see these relay contacts. Just trying to look at these, see if I can see anything which looks out of place. They seem okay. Can't see anything, looks like it's stuck. Doesn't mean it's not. It's obvious though. So check power supply, then we'll put in operate mode, check the input voltage, and we'll also need to have an input voltage. Let's do that. Right, so it's about ready to start doing some voltage checks on this thing. So we need to check the voltages look okay. Main power supply rails first, to see if they look kind of right or not. Then we'll check the voltages on the op amp, which is IC4, which you won't be able to see me doing. Maybe I can move the camera around, not sure, maybe I can. And then we'll see how we go. See what we get from that point. So it has to be in operate mode in order to get the input voltage to pass through. We'll turn the PDVS2 mini on. Set that to 100 millivolts because that seemed to do something before. Turn the power on. So in standby mode, the input's ignored. Let's stick this on a chassis point because I should be able to get any chassis point and measure voltages from that. So pin 4. Maybe not that one. Maybe not. Here. There we go. Stick that over there. So it's obviously minus 15 volts, which is looking pretty close there. And pin 7. Yep, slightly offset though. Probably doesn't matter. So those look alright. So let's check on the inputs, which are pin 2 and 3, I think, is that right? Yes, pin 2 and 3 of the op amp. I'm still going to keep it at 0 volt referenced. So this is with no input, don't forget. Nothing there. Nothing there. And the output is pin 6, I think. A dodgy connection. So you're getting negative 6 volts on the output. It could be that the offset is not set correctly on this. Anyway, we'll turn the input on and we'll measure that again. So pin 3, pin 2. So those two aren't balanced. And pin 6 is still minus 6. And we're getting 800 milliamps current. What's that telling us? Not much, apart from the fact the input's not balanced. It would seem. Curious. So IC3 is a different device type, it's a metal package. I'm slightly suspicious about IC4, the fact the inputs aren't the same voltages. The inputs should be the same voltage, they should basically be balanced out. So the fact there's an imbalance, that makes us suspicious about IC4 straight away. Let's pop that device out and see what we can get. So that's a standard pinout, is it? IP07 standard pinout for Siglent op amp. I'm going to assume it's a standard pinout. I'm just going to swap it with whatever this is. That's a TL081. Is that right? No, I need to check because I'm suspicious. OP07 op amp data sheet. Need to make sure I'm not plugging in something which is different. And I also want the TL081. Come on, PDF. So the OP07's got trimming. Go on, where's the pin up? OP01 does not have trimming. But I should give you a functional test at least. Yeah, I'll be able to do a functional test, but it doesn't have trim. Okay. I think I must have an op amp here which got trim on it, surely. Must have one. I think I need to get some AP07s. Or perhaps a more modern part, which is better. So this will lose the trimming ability. Right, so I've plugged in a OP... No, I haven't. And you know what I've also done? I've done this wrong. Bloody markings went obvious. I must put it upside down. That would be good. Put it in again. So I've put in a TL081, which is similar to the OP07, except it doesn't have trimming. So it's got no trim capability on it, which may affect its accuracy. But for the time being, it's just good for a pass-fail kind of test. Is that op amp good or not? And we'll just see if this changes anything. So we'll try this again. I'll turn the output back off. Is that on? Let's enable the output. That's doing 1 amp. 100 millivolts. Okay, if I do 200 millivolts, yeah, that's changed again. So, okay, let's measure some voltages. So I'm on 100 millivolts again. Check pin 2. 0.106, I think is what we got before. 103, that's closer. There's on pin 3. Pin 6, exactly the same. So that op amp doesn't appear to be the actual issue. It's probably slightly different because of the trimming, where this op amp doesn't have trimming on it. So that's likely what's going on there. So not that one. And guess what? That's the only one that plugs in. All the others are soldered in. Maybe someone's already changed it. It does have a white dot on it. So it didn't really change anything. chit chat. So, we have a negative bias on the output. Why would we have a negative bias on the output? We've got 0 volt Zener back to back here, which means it'll be limiting the output voltage maximum on AC. Being back to back means it limits AC, not just DC. So both polarities, it will handle them. So one would be, if it's going to the negative side, it would be one diode. If it's a positive side, it would be the other diode. And it's pulling down, it's pulling below 0 volts. So it's not these which are causing that voltage to be lower. So the voltage being lower is either the op-amp itself driving it lower by a lot. It's 6 volts, don't forget, difference. I think it's likely to be this feedback here that's being pulled negative 6 volts. Surely not. Could be. So a negative voltage on here would be turning on this transistor harder, because it's a PNP, so therefore you want a negative, which would be turning on the positive side. Because that's a feedback through a 1.5K. So does that mean we're getting 12 volts at this point? Or negative 12 volts? Actually, that's the one we just tested. Oh, I'm getting this wrong, aren't I? That's the one we just did, that one there. Not this one here. Get this backwards. So here we're getting that negative voltage. And that's not fully feeding back, so it's not coming from that side, it's coming from this side. And we replaced the op-amp and didn't change that voltage, which means it must be coming back from in front of this side. So it's a negative leaking through, which must be coming from this section, or where does that go? R61. That's a comparator of 0 volt reference. Or comparator reference at least. So that's a feed into that comparator. If the comparator output's bad, or if their comparators fail, maybe it would be causing a backfeed, which might do it. That's really close to that circuit. Or we've got an issue with something else down here. I just find it weird it's got a negative offset on the output. That's DC blocking. What's a 1N4735? What voltage is that? .2 volt Zener. Well, that sounds familiar, doesn't it? So that's from a minus 15 volt supply rail. Nah, it's not that side. Can't be going through that diode. But if you've got that 6 volts there, that could be that transistor. Bypassing through that transistor. Unlikely though. So that TR2, maybe I should check that, see if that looks like it's okay or not. If that looks okay, check that Zener. Yeah, that transistor and that Zener, I think that's what we need to check. It's also possible that one of these is bad and dragging it down. Mind you, that's the upper common, so probably not, actually. It's 470 ohm. That's that. That's an output feedback, kind of. Yeah, I think I need to check those Zeners and those two transistors here. Mostly this side, I think. R10 feedback. Well, the thing is, the voltage was actually, well, the current was changing with the input voltage, so there was some kind of control there. If there was no feedback, you'd expect it to not change with input voltage, because it'd either be on or off, it'd be turning into a comparator if there's no feedback, I think. So D6, TR2, I think they're the things I need to look at. Let me find them. Well, there's TR2, it's a big bloody thing. And it's got some circuit modifications in the area. They look like the factory. I think that's D6, right next to it. There it is there. Okay. So, trying to get onto the pins is going to be tricky. Diode mode. Well, the Zener's looking kind of alright. Let's check D7, which is this side. It's looking kind of okay. Alright. This circuit's been modified a little bit by someone. So over here it's got some changes. It's got a microcapacitor across here, crossing this diode, to a resistor which goes onto this post here, which has got a junction set up. This side's got a similar modification as well. It's got an extra capacitor and a resistor, which is basically looking like, well, they're in series together, which is over here. It's mimicked on this side, and they look like the same kind of parts as the factory using, exactly the same resistor type. So I'm pretty sure that these are factory modifications. So I've got no reason to suspect that they're bad at the moment. Should I check the capacitor's not dead? Nothing outside. 1.3 volt leakage there, could be just circuitry around it. Yeah, probably is. So, how do I get onto the pins on this bloody device? There's one pin there. I'll get to that one. And there's one pin there. And where's the other one go? Yeah, not really getting much in the way of sensible readings from that. Not sure. Nothing obviously bad though. There's no shorts. Let's check this other diodes down here. That looks fine. There's an equivalent on this side. Yes, there is. That's fine as well. Alright. Those also look fine. Okay, let's look at something else. I haven't heard relays clicking. Let's go back to that part. All the relays are operating. But I think I can see a problem. I can see a problem. Aha. This requires a bit of camera view. And my camera just turned off. I don't know how easy it is for me to get my camera in here to see it. And of course the light's reflecting on it. Which one's? That one. So, as you can hear, I've got it powered up. You can see the relays energizing as I go through each one. So that is the 100 microamp range. That's 1 milliamp. That is 10 milliamps, 100 milliamps, 1 amp, 10 amps. Then you can see how far these are moving. See how much distance these are moving by. Look at the 10 amp one. Look how little that 10 amp one is moving. See that? It's barely moving. Is that a clue? Why? Yes, it is. Let's get really close. Can you see something wrong there? You see how much moving that one is? So that back one. Let's see how much this one here is moving by. And the 10 amp. Now look at the relay contacts. So if I look at the one behind it, might just be able to see them in there. So you can see those relay contacts opening and shutting. You can see both pairs of contacts, and you can see them opening and closing. But now look at the 10 amp relay. See those relay contacts opening and closing? No? That's because they're not. It's a bad relay. One of the original suspicions. It's not releasing. Relay's had it. Very interesting. Nah. Definitely not releasing. Okay, that relay's got to come out and be pulled apart. I doubt I can get that cover off. I can say that hiccuping. I doubt I can get that cover off without taking the relay out. Yeah. Got to get that relay off the board. It's soldered in. Move some meters out of the way. We have found the problem. Or at least we found a problem. It may not be the problem. You're dizzy yet? Right. Hopefully we get to the bottom of the board from in here without having to take the whole board out. Pretty sure we can get it from here. Not 100% sure, but pretty sure. Plug out. Oh, come on, slide. Oh, it's not going to slide. Oh, I think I'll take the feet off as well. Okay. Looks like they screw into the casing now. I don't think I did have to take those off. They still don't want to move, so I'm taking it anyway. At least we know it's not in the way. Yep, it wasn't those. Is it just stuck? Maybe. Yeah, it's just stuck. There we go, really tight. It's got a dent, that's why. It's got a dent over here, which is making it stick. Let's fix that before I forget about it. I was going to bug me, I'm going to put it back together. It's probably been dropped in that corner or something. The other one's also a bit bent. I do. Everyone thought I was a bit funny. I was buying these hammers all the time. A whole bunch of different little hammers. Really handy. Right. So relays are here. This one we need to get to. And there's a bit of dust and fluff in the bottom here. Anyway, so we'll get this out. It's a shame it's not a plug-in relay. That would have been much easier. But, oh well, can't be everything. Interesting, it's got another bodge here, just like a voltage regulator. Interesting, it's got a 7812 voltage regulator bodged in, seemingly to power that relay. That's interesting. Well, it's not actually releasing. So when it's under no voltage, it's not actually moving out of the way. It's not like it's a voltage leakage problem where the voltage isn't being driven hard enough. Let's make sure it's still shut. Yeah, it's definitely not fully off. It's still slightly stuck, so yeah, it's not like the voltage is being held on or anything like that. So let's get that out. So this is the bottom of the circuit board. You just take the bottom cover off and get access to it easy. It's really good design like that. It's really nice. This is the relay we need to take out. Loads of pins. It's a good job I've got a desoldering gun. So I need to use that to take all these out. And then we can take the relay out and strip it down and try and fix it. Chat chat. Defpom, yes, exactly. So you already get to use a hammer, yeah. You don't have to get to use the hammer, we're doing electronics. So before I try and desolder this, I'm going to put some fresh solder on, because this is a relatively old unit. So I put some fresh solder on there. It will make it easier to desolder it. That makes sense? I've still got this massive tip on there. That's probably fine though. Might be helpful right now actually. It's got a bit of thermal mass in this area. So there's blue wire here which we need to move. Don't forget it goes to the top pin. You got that? Top pin, not the bottom pin, top pin. Right, let's desolder this thing. And you thought it was noisy before with the hammering. Okay. Big ground plane here, lots of thermal mass. Biggest trouble is this is a double-sided board, so there could be issues with connections on the other side of the board, trying to get the heat through to those. We'll find out. Right, let's see about moving these legs, see if they move. That's a no. Barely. Yeah, that's going. That's not. No. It has not desoldered very well. That one has. That one has. That's what I thought. I need to go over it again. It's got the top side connections which are causing problems. That one's free now. This might take a few goes to get these off. Didn't do that one, did I? That's free. That's not. No. No. Yes. Yes. Kind of. Barely. Yes. 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 Nope. Nearly there. We're getting there. I'll come back once it's done. It's definitely being stubborn. Let's recheck where I'm at. It's still attached. That one's off. That's off. That's okay. That's not. That's not. Not great. That one's free. That's not. That's not. Those are being a pain. That's free. Might have to do the hot iron technique instead. Yep, that's that one off now. So that's those. Those 8 are good. That one is good. That's not there yet. That's good. That's good. So I've got 3 pins we're trying to desolder. But that's probably good enough for me to lever it out. So I've got 3 pins I can't desolder, so what I've done is I put some solder back onto them. And now, because of where they are, means I can probably actually just wiggle this thing out and just heat them up and just gradually lift it out that way. That'll probably work. And just go backwards and forwards between them. There we go. That's it. It's out. Let's clean these holes out. Hopefully there's any traces on the other side, they're still there. Yeah, that all looks fine. There you go, there's the relay. R10E2Z4J2.5K. 8.4 milliamp DC. So, can you see the contacts here? They're basically all shut together. Yeah, it's all stuck. So, they're probably pulling apart and see if we can get those apart. Thing is though, there's a lot of contacts to deal with. Got a locking piece there, in there. So it looks like I might be able to get this apart by shoving my tweezers up the side to push the sides out from the locking pins. And we'll see if we can then pull it out. I'm not sure it's going to work, but it's worth a shot. It does not want to come out still. No. That's going to be a pain. Wasn't that easy. Come on. I think it started to move. Come on, you bugger. Yeah, it's definitely started. Okay, I've made some progress. I've got it started to move. I think we're just about ready to get it out. There we go. Now, can you see the contacts better? So now you can see those contacts here are actually stuck together when they shouldn't be. So something's gone wrong here. See, that's the plate. See that move? See, when it's pulled fully out of the way, those contacts here are still shut. So, what's going on here? They are not welded shut. Not quite sure why they're not working right. There is some definite discoloration on a couple of pins though, and a couple of contacts. So that's a bit interesting. It almost looks like it's got an issue with manufacturing, to be honest, because the clearances just aren't moving that much. And if I actually bent these pins a bit, they might actually be alright. It could be something wrong with the actual read contact, the switch mechanism here. There's an awful lot of play in this, but then this was shifting when I was trying to pull it apart as well, so maybe it's because of that. Maybe there's a problem with the movement because it's all been pulled up a bit. Maybe that's from someone else playing with it as well. I think it's more investigation. Come on, chat. Well, it's only for the feedback circuit, so it's not. It shouldn't have had any current going through it. So the actual relay is this one here, the 10 amp relay. So all the contacts are in parallel, obviously for lower resistance. So it also makes me curious, why would it need to be in parallel? So the high terminal comes straight from that drive. Unless that relay there is not turned on, maybe? Why would that be going through there? I don't know why they'd be burnt. There is some discoloration. But I don't know why it would be, because I mean that's a precision resistor to ground. And that's going down to the high terminal. It also makes you wonder a bit if this resistor ladder here is damaged as well. Got these individual resistors down here, which are doing the resistor ladder for the actual current ranges, like a Kelvin Varley divider. So that is coming down to this big precision resistor, which is that massive one which is standing up at the board, I think. So I don't know why that would have gone, unless it's that slow resistance path through there, but I don't know. That's interesting. Hey Ian. Bad relay. 10-amp relay is not moving correctly and the contacts isn't stuck shut. Well, they're not actually stuck shut, but they're not actually moving away from each other properly like they should be. I wonder if I've got a relay like this somewhere which I can put in. What voltage was it again? I've forgotten. Maybe I've forgotten because it doesn't actually say what the voltage is. It just says 8.4 milliamp DC. R10 E2 Z4 J 2.5K. And contact resistance is 2 amp at 28 volts. Somebody overloaded the thing, yes. So R10 E2 Z4, and we'll see what we can find from that. It says 24 volt for that type, but it might not be the same one. That says 24 volt. These are all V series. Here we go. R10 series. Let's find a data sheet, hopefully. How do I know which type it is? I'm just trying to read the data sheet to find out which one. I think I'm going to sneeze. Q's. I'm looking for something which looks vaguely familiar. Got J 2.5. It's got S 2.5. J 2.5. Here we go. That says 6 pole. And 8 pole. Oh, here we go. It's well, it's just dual pole, wasn't it? But that's got a lot more pins in that on the bottom. It's only got 2 poles. 3 poles. It's got 3 poles in the drawing. Maybe it's 3 poles. Yes, it's 3 poles. So 3 pole, 2.5. Coil resistance. Yeah, okay. I'm going to have to work out what the bloody voltage is based on resistance and the current. Tedious. Not sure. Spell it out. No, it just says that. Well, that's tedious. Okay. So I'll shove this up in here. I'll save this data sheet. R10 series relays. Save that. I'll open up in a second. Oh, I've already got an R10 series relays. Ah, I thought so. I've already saved the series before, and these are very similar to the ones that are in the Fluke 343A. That's exactly what I thought. These are substitute parts. So we've got the J series, which is this one here, J2.5. So maximum coil was current is 28. Operation is 5.8. And they said 8.4 milliamps. I guess that's nominal, what I'd normally want. I can't bother working out the voltage for that. It must be 24 volt, really. Sure. It must be 24 volt. It's interesting the way it's got that voltage regulator added onto there, though. On the actual coil for that one. So ILF. ILF here, ILF here. But there's only 3 contacts. Why is it showing a fourth one? 12, 13. What's the pin out? Well, it's not on the side, I have to go over that. So 12 and 13. That are pair of contacts. I'm trying to make sense of this bloody contact diagram. That is not a 3-pole relay. .24 volt relay. Okay. I do have some 24 volt relays around the place somewhere. Whether or not they're the same pin out, I don't know though. But it may affect accuracy. 4-pole, you reckon? Anyone reckons 4-pole? Yeah, I'm just confused by it. Oh, here we go. I should have gone a bit further, shouldn't I? It looks like this one though. But it could be that one. Yeah. Okay, so it's got unused pins. No, this one's fully populated, so yeah, 4-pole. You guys are right. Okay. So the centre pins are the commons and the other ones are the switched sections. So you're looking for that. Okay. Right, now I understand what the diagram's showing. Right. Excellent. So 12 and 13 are the normally open of that pair. That's showing shut. Okay. And yet those are open. How can they both be different states at the same time? Or is that showing in operating mode? Hold on. 15, 16. Oh God, where's it gone? "15, 16 is open. They are open. Why have I got a discrepancy between these diagrams then? Between the states they've got those shown in. Surely if 12 and 13 are shut, 15 and 16 should also be shut. Maybe it's just the way they've drawn it. Okay. So I need a 4-pole relay to replace this with. Yeah, looking at the damn relay hemp here. But it wasn't clear. I looked at the relay itself, not looked at the casing, but yeah, anyway. Yeah. I'm pretty sure this is the same relays used in the Fluke 343A. I remember looking at these, and they were hard to get. Or this was a substitute or something, potential substitute. Does that mean I've got a spare one from the Fluke 343A? Maybe. Or should I just try and bodge this one up and make it work? Bend the contacts a bit and try and clean up a bit. But something's definitely wrong with that alignment. I don't know what. Maybe it's got hot and it's just warped it all or something. I don't know. American Zettler, yeah, that's right. But the R10 was a substitute which could be used. I'm pretty sure. About that one. I'm pretty sure all this is doing is linking this one in place. I think this is drawn wrong. I think they should be normally open as well, just like these. Like all of these are shown as normally open, but these ones aren't. These all shut as closed. I don't think that's right. I think they should be shown as being open as well. So I think without that relay in place, so as it is right now, I should be able to power it and test the other ranges out with no relay in there. Assuming this is drawn incorrectly. Because based on the relay pinout, here, make it bigger. So it shows 12 and 13 as being normally closed. But also shows 15 and 16 as being normally open. And they have to be the same states. So I think they've got that drawn wrong. Oh, the shunt, that's a big shunt. It's a massive metal shunt. The shunt looks absolutely fine, it's huge. Yeah, well, let me look at the actual PCB and see what that looks like. Can I see anything from that maybe? I don't know. Let's look for 12 and 13, so middle pin and bottom right. So we've got 3 pins are common together in the middle ones. So pins, so it's 6, 15 and 9 are all joined together. And so pin 12 is isolated from the rest. Okay. I'll just follow the trace down from pin 12 to see where it goes. So it goes to a 0.909 ohm resistor. R43 is a massive bloody thing, which you can't currently see because I've got it on the wrong camera. That's fine. I don't believe that R43 is a problem because there's a big metal plate basically. So I think the drawing is wrong. So R41 goes to pin 12. Yes. And no, pin 13. R41 goes to pin 13. Pin 12 disappears off to a couple of things. It goes to R32 as one of the devices it goes to. I can't see where else it goes to. It goes only through other relays. So R32 and R41. Let's see if that matches up with the diagram. So pin 13 goes to R43, it does that. And pin 12 goes to a few different places, goes to all those other relay contacts. R32. So yes, I think this should be drawn as a normally open, not a normally closed. I think that's an error. So I think if I leave that relay out, it will work on all ranges apart from 10 amps. We should give that a go. Make sure there's no pins joined together, nothing shorted out when I've been taking it out. Move this off here. I'm really puzzled by this extra voltage regulator in here. I mean, it doesn't look like it's original. I mean, it could be. It's been done nicely enough. Where's the red wire go? That gets attached over here. So that's interesting. This is coming across to here. I don't know. That's an interesting modification. I might need to look into that some more to find out what's going on with that. Yeah, make it bigger so you can see what I'm talking about. Yeah. Alright, so that regulator, the positive supply from that is coming across to this point over here on that transistor there. So that's a bit curious. We've got some kind of, it's an output going to here, and output also going to that relay there. So that's interesting. Anyway, let's make sure there's no shorts across these connections before I do anything else. Don't want to make it any worse than it already is. Yeah, it looks right. Okay. So if this works, all I've got to do is either repair or replace this relay. He wants this one here. But it could have also done some other damage with it being feeding back at the wrong voltages. It could have caused some other problems with the other resistors. It's possible. 10 amp range, 10 amps, that's on standby. PDVST Mini. Right. Kind of focused. Right, so I've removed the resistor. Sorry, that's a great start. I've removed the relay, so the 10 amp relay is now not installed. I believe there's an error on the diagram where it's showing a pair of contacts as normally shut instead of normally open. I think that's a drawing mistake because it doesn't seem to match the actual specs for the relay. So, unless there's a variation of relay which I can't identify from the data sheet, but it looks to me like it's wrong. So I'm going to test everything apart from the 10 amp range. And now that relay's not there, if it was causing a problem before by those contacts being shut, the other ranges should now work. That's the theory. So I'm going to inject voltages for this, as I did before, in order to try and get a current out. Obviously set up, I want to be on DC. Turn the power on. So no current so far on 0 volts, still 100 milliamps, sorry 100 millivolts. We've got nothing, but some 100 microamps, so I put it on sharp anyway. So it's not doing that massive voltage we've seen before, sorry, not doing that massive current we've seen before. 1 milliamp, still nothing. Oh, I'm on standby, that would help. Operate, let's do that. There we go, so 100 microamps, operate mode, nothing there. 1 milliamp. Nothing showing up there. 10 milliamps. I've got a really low voltage gain right now. So it's not doing that massive current it's doing before. So 1 amp. Okay, let's change voltages. Let's do 1 volt in. Still got nothing there. Okay. So now we actually have no output whatsoever. Do 2 volts in, which is the maximum it's supposed to take. And we still have nothing at all coming out. So, we've changed it. We have proven it's something to do with that relay. So maybe that relay contact thing is correct, that relay connection is supposed to be shut. Which is the pin 12 and 13 of the 10 amp relay. Because now we've got no output whatsoever. So, it's no worse than it was. It's just different. So I think we've got something right. Unless it's caused some other damage to some other parts of the circuitry, which has then caused them all to fail. It's possible it's affected more than just that one section. So if I measure on IC4 now, we'll see if that looks any different to what it had before. What do you reckon? Let's go plain DC, quicker. Right. So, with 0 volts input, that's on pin 2, that's on pin 3, that's on pin 6. I've still got it at minus 6.7 volt. So we're putting 1 volt now. With 1 volt we're getting minus 6.6 instead. You go, getting minus 1 volt that side. Minus 1 volt that side. Okay. So it's doing something. Okay. Maybe the drawing is not wrong. I'm thinking I might need to do something with that relay and get that relay fixed and go from there. Or is there still an issue with that op-amp circuit? I mean, the inputs are balanced. The 2 and 3 are the same voltage, which is what they're supposed to be. So that's good. But the pin 6 output's interesting. But it may not matter. It may just be the way the circuit's working. Things that are also read relays along there as well. But I think those are from the control circuitry to turn the relays on. So it's got read relays there. Yeah, there's read relays from the control circuit, which is for the remote section. So I think those read relays are turning on the coils on the actual relays. So I think I can probably ignore those read relays because there's one in front of each relay. So I think that is what those are for. Okay. But there are some interesting aspects on this as well. Like there's some missing components, but they look like they've never been soldered. So RV12 is missing, C14, C27 on this side. On this side we've got C31, C20, C25, C28, R15, C29, C33. There's an awful lot of parts that are missing. I've got C30 and C24 over here as well. I don't think it's been someone putting in here pulling parts out, because I don't look like they've ever been desoldered. They look like they've never been done. There's almost so there's never been a part in there. So I think that isn't the problem. I don't think there's missing parts. Could be. But it looks like, you know, this has been modified later on anyway, so maybe those missing parts are to do with the revision. No, I didn't solder back the blue wire. I wonder if that's powering the other relays. I wonder if that's doing a feed somewhere else. That's a point. Good point, Ian. Is that the plus 24 VR supply? Is it? Where was that? Is it this? I wonder if it's that regulator there, which is generating the 0.24 VR. But then I'll still get indicator lights, which are coming from the same supply rail. See, it comes from the same supply. Oh, that one does. Oh, so does that one. Actually, yeah, they both still do. And the indicator lights are still working. Maybe the relays weren't engaging. I should check that. Yeah, good call, Ian. The relays aren't engaging. That must be a factory modification then to make that work. Let's solder that back on. Yeah, I know I'm at a shop, but it won't take me long to do this, so just hang on. Be with me. Okay. Okay. That was a good call, Alan. Ian. Good call, Ian. I was assuming that was only for that relay, not for the whole bank of relays. That was a mistake. Okay, we'll do this again. Remote to start with. And you can't see what I'm doing at all because I didn't have the thing on the right thing, so it didn't switch because I left the cursor up the top. Deary me. There we go. Okay. Right, so I left that blue wire off that relay, which I think is actually the main 24-volt supply rail for all of the relays. So, I've put that back on again. That's pointed out by Ian Johnston, who's in my chat right now doing the live stream. So, let's try this again. I've now reattached that wire. We'll put power on, put it in standby, power it up. Currently set at 0 volts input. Let's do 100 millivolts. Turn the output on. On a microamp's nothing showing up, but it's not surprising because it's probably below what the meter can see. Let's do 1 milliamp, 10 milliamps. Oh, we've got something there. 100 milliamps. Yes, look at that. 1 amp. It's doing something. So let's go to 1 volt. There we go. It's doing something. That one's not right. So I think it should be basically like a 10 to 1. Or 1-to-1 ratio, so okay, that's doing something. So 1 volt is doing 10 milliamps, so it's like full scale 1 volt. That's off. That's off. 10 amps should do nothing. Yeah. Okay. So it is kind of working. That one's got better now. Interesting. Now that's right. 1 amp is still down a bit. On the switching is cleaning. There you go, now it's perfect. Okay, it looks like the switch might need doing. It's possible. Well, it could be something else going on there. Okay, if I do 2 volts, which is the maximum, put it on 10 milliamps so we can see it. Got a 2 volts, there we go, we're getting 20. Okay. So I can do 100% over range. So yeah, that's definitely doing something, and 10 amps will do nothing still. So yeah, okay. It looks like the other range is basically working, but we've got some issues. It could be adjustments because someone's been playing with it. Or it could be issue with the switching or dirty relay contacts with feedback. In fact, dirty relay contacts is actually quite likely. I might have to pull every single one of these relays out and strip them down and give them a clean. That'd be tedious, but it's working. And everything apart from the 10 amp range, which is the range I want it for. Yeah, the 10 amp range is the one actually the range I wanted it for, because obviously the actual calibrator can't do that. So of course it's that one which is broken. Right, back to the chat. Yeah, it's got individual pots, but it wasn't a consistent change in reading. So as I was switching between them, so as I was switching between each range, obviously energizing each of these relays, so it'd be whichever ones those ones are, I don't know, the 1 amp range and the 100 milliamp range, those two there, which are these two relays here, is it? Yep. So those two there, which come across to being relay E and relay D. So D and E, those two weren't giving consistent readings. As I switched backwards and forwards, they would be different every time. The other relays were okay. Those ones weren't doing that. So inconsistent readings through relay contacts. So it's not this switch, it's the relay contacts, because the switch is only switching relays. So those contacts won't be the problem. It has to be the relay contacts. So that means I've got to pull these two relays out as well and give them a clean. Yay! Yeah, I'd take them out and clean them. I'll strip down and clean them. Because I did that with the Fluke, the 343A. I had to pull those relays out, strip them down and clean them, and I had really good results with that. It's been rock solid ever since, so I've had no problems with it. So it's only 2 relays. It's not like the Fluke where I had to do 20 or 30 relays, whatever it was. It's got heaps in there. So the pain is not so bad. The problem is that I've got to desolder the things to get them out. That's the pain. Yeah. So I think that's what I need to do, is clean those relays. Right, I'll talk about that in the other video. Just go and do that. Move the cursor out here, so I should switch over. So with the 1 amp and 100 milliamp ranges not being consistent currents, each time I switched in and out, the current was different. It wasn't the same every time. It won't be the switch itself. I was thinking this can't be right, because the switch is only controlling the relays. The actual current, there's no current or feedback going through the switch itself. It's all going through the relays, which means the 2 relays which are doing those 2 ranges have to be having issues. They both must need the contacts cleaning. Now, if you work them enough, you might actually find they come right and clean themselves. You know, they have a natural abrasion anyway, but now moving is a slight sideways movement across the contacts, like a slight cleaning movement. But if those ranges haven't been used much for a very long time, they will actually get a bit of oxidization on them, and that will cause problems. When I did the Fluke 343A, sorry, that's not right, the Fluke 5450A, my resistance standard, that had issues as well with relays. I ended up stripping every single relay from that thing and cleaning every single contact. It took me hours, but it needed doing. This appears to only need it on 2 relays. So, at least so far, I might have to look at these other ranges more thoroughly to be sure they're okay. So I've got to take out those 2 relays, but unfortunately I've got to desolder them like I did with the other one. But I'm not going to record that process. I'll just pull them apart, clean them, put them back in again. And I think that'll fix those 2 ranges. I think that's all that's going to be wrong with those 2. So then that 10 amp range, I've just got to sort out a new relay for that. It could still be an adjustment issue on this one. It did seem like it's quite a long way out. It's like 10% out on this one. It could be due to bad feedback, but I don't know. It could be either way. So I think my suspicion is clean those 2 relays, pull those out, clean them, put them back in again and try again. And we'll see if that improves that situation at all. I suspect it will. Then this leaves me to try and fix this 10 amp relay, which is going to be interesting. Excellent. Did I switch? Swap the relay with the lowest range of same relay. So okay. Well, I have to see how I can find these relays. I mean, if I can buy a brand new one, I might just buy a brand new one. I don't like my chances though. Let's put the full code in and see if I can find anyone selling these relays. Is it right? R10 E2 Z4 J2.5K. Digipart. eBay. That does not say. That's an E1, not an E2. Yeah. No mainstream suppliers, it looks like. Of course it's going to be inconvenient. I imagine contact resistance is going to be an issue on these because it is a precision instrument. So contact resistance will be a consideration, which is why they've got so many poles in parallel in order to reduce that contact resistance even further. So yes, that's a potential problem. So with that 1 amp range being 10% out, there could be relay contacts. It could easily be that. It could also be that the other range has caused a problem. It may have damaged a resistor. So it's got that 0.909 ohm resistor in there. I should better measure that. Okay. I'm getting 1 ohm, 1.01 ohms, and dropping slightly. Lead resistance to take that out. That's about 0.1 ohms. So, yeah, that's really close to being 0.909. So I think that resistor's okay. It's not like it's damaged, I don't think. Let's check the 0.4, well, resistor 43. Let's measure that one. I'm getting 0.22 ohms on that. Again, lead resistance 0.14. So across the current side of that resistor is 0.22, so it's 0.08, is it? And from the sense terminals, it could be the other way around actually. I'm getting 0.27. So that'd be 0.13, wouldn't it? What was that supposed to be? .101. So 0.1 ohms. Yeah, it's close, isn't it? It's close. So from one side of R43 to the other side of R41 should be basically 1 ohm. 1.01. Right, no, hold on. Yeah, 1.01 ohms. Probably need to be doing a full wire resistance for this, but So 1.01 ohms from this side here to this side here, give you 1.14, and I've got 0.14 lead resistance. That's 1 ohm. So I don't think there's a problem with resistors. I think they're fine. At least the main current shunt ones. Right. So we've definitely got a lot of progress here. Oh, I was going to sort out that relay. Yeah, I'm going to have to look into this. I mean, if I can fix this relay, I'll be happy, but we'll see how lucky I'll get with that. That could take a while. Hey, George. Here's George. Old straggly cat, this one. Well, in fact, all my cats are old, but this one's the one which looks the worst. Anyway, okay. About $80. The door's not shut. It's just ajar. $80. Is that just for that relay? Is it? On Amazon. You reckon? Amazon. That's not exactly the first place I think of going for electronic parts. Scrolling. Lots of unrelated things, which is amazing seeing the search term I put in there. Oh. No. Come on. This has been so slow today. Come on. No. I don't see how you can pick up all these other things which are completely different to the thing I'm searching for. I'm yet to find any relays. Unless you're referring to something else, or I don't know, maybe my search term is not good enough. No, nothing came up from that. Take the dash out between E2 and Z4, you reckon? Okay. Got some TVs and stuff. Might be giving me different results to what's giving you. I've got 3 less results, but I'm finding SSDs and TVs and glasses and Visa mounts and Oreos. No, relays. I'm not finding results of relays. It's weird. Ah, okay. Right. It seems like it's not offering me that one. I don't have a purchase link. It's just there. Oh no, there we go. Now I've gone into it. Yep. $80. Indeed. With $68 delivery. Yeah. Okay. Well, that'd be last resort stuff. If I can do it without that, great. But the Wembley's R10 relay has been mentioned for the Fluke 5450A as possible replacements, but I ended up doing something else. So I might actually have a relay I can put in there, because I did get a replacement relay for one which was being dodgy, wasn't switching nicely, and I replaced it. And the one which I took out I've still got. It was switching, but it wasn't switching well. And I cleaned it and then put it away. So I do actually have the relay pulled out of that. Yes, that's $140 odd delivery, well, including delivery. That's in New Zealand dollars. It's like 50% more, so it's another 70. So it's about $200 New Zealand for me to get a relay. Yeah. Does that mean that... Surely it doesn't have current going to the relay though, because it's connecting to that big shunt into the feedback circuit, is it? Surely it's not got current going through there. So the low side's going to the common. The high side is going through all this stuff, which then goes through this network through to the 0-volt rail, and that's push-pull. It is. This relay's passing current through it. This relay's passing through 10 amps. These relay contacts only rated at 3 amps max. So even using 3 contacts in parallel, that's 9 amps. It's being underrated. Oh, that's unbelievable. So what we've got is we've got two. Yes, I see how this works. Now we've got a parallel Kelvin-Vardy divider. One is the current side. So one side's doing the current, passing the current through, and the other side is passing through the sensing. It's basically two parallel paths which are interconnected to allow trimming. Yeah, okay. I see how it works now. Right. So yes, the current is passing through this relay, and that's 2 contacts is fine, because that's going to allow 6 amps potentially. It's a 1 amp range with 100% overrange. So at most that's going to be 2 amps, which would be why these two here, the 100 milliamps and 1 amp range, are showing up as being dirty, because they're passing a little bit more current. Although you think current might actually help them a little bit. Yeah, and that's why this one failed, is because it's even using all 3 sets of contacts. That's only rated at 9 amps, and it can potentially do up to 12, I believe, maximum. So even at 10 amps, which is the maximum of the range in theory, without going over range, that's still more than a relay contacts are designed for. So this relay's actually not got enough contacts on it. They needed more contacts. Which is probably why it burnt out. Yes, the factory relay is actually not up to the job. Wow, that's not good, is it? It needed one more set of contacts. Which is why it's burnt. Someone's been using it at maximum current and switched it with the current active. Yeah, okay. So I did read a little bit of the manual, or one of the manuals. I did read a few pages. I skimmed through it. I remember reading in there about not switching it in operate mode. So when you go to standby, change currents, and then take it back out of standby. That'll be for this switching contact resistance. So obviously when the relays are switching, you've got that high current. And if you've got one pair of contacts which makes contact before the others, those will arc more likely because you've got to take the full current through those contacts. So likely what's been happening with this is that this has been used badly. Someone's leaving in operate mode, changing ranges in its high current ranges with a low connected, which has then resulted in arcing of those contacts and which has destroyed the relay contacts. Yeah, that all makes complete sense. If it had one more pair of contacts, it might have actually survived it. You're exactly right, Henbei, that's what I meant about the individual pairs of contacts not making it at the same time. So, this is why it says in the manual to put it in operate mode only once you've got the range selected. That's why it says that. Okay. It has to give contact time for it has to allow the relays to be shut. Because obviously that amp rating as well will be based on an active switching, right? So it may be that 3 contacts is enough if they're already made. So if they're already closed, it can handle 3 amps, or more than 3 amps per contact pair. But it's a switching current, which is what's stated in the data sheet, because it's a relay, right? It's switching. So replacing like for like might be okay, as long as it's used correctly, because it's obviously rated for the switching action. Right. I think I need to replace that relay, really, to be honest, to be comfortable with that, because those contacts are burnt as well. You can see it's had some arcing going on there. So even if I do get it working, I won't completely trust it. I might have to spend $200 on a relay. Damn it. Why is it when I do a search term for that one which you gave me, it does not pull it up? But obviously the link is there, which you gave me. That's weird. $200 for relay is horrendous, but you know, I think it's going to have to be something I need to do. Because contact resistance is important. Right, there it is. Let me look on eBay as well. See what's on there in case I get lucky, you never know. No. This is even worse. 305 New Zealand dollars with $470 postage. Here's that one which is $160 for the relay, $235 postage. That's an E1 version, it's not quite the same one actually. E1, no I don't want E1. Why does it bring up E1? I want E2. E1, no. Well, that's the only problem, isn't it? Yeah, it's not got exactly the right term there. So it looks like I've got very little choice here. Yeah. Damn, that's expensive. So it's given me now a price now in my proper system. For some reason it's changed. Now it's New Zealand dollars instead of US dollars. Comes out as $240 for that relay. Yeah, I don't want to spend that much bloody money on a relay. I mean, $100 I'd be sort of, yeah, okay. But $240, that's really getting up there. I mean, that's getting... Oh, if they're that much to buy, it'd be cheaper for me to part this thing out and buy another one. Strip all the existing relays out of there, sell the relays on eBay, and buy another one. It'd be cheaper. And I'll still have spare parts. Yeah. It's frustrating. Oh, I have to think about what I'm going to do about this. I have to do some research on it. I may even look at the swapping the relay to a different type. I mean, it's not like it's going to a socket. I could always find something similar, maybe. Same pinout. I don't know, like contact resistance becomes an issue, doesn't it? Yeah, I don't know, maybe I need to find some smaller relays and parallel them up and then stick in like 2 relays or something and really beef it up, and that help get the contact resistance down at the same time. Because the more in parallel there are, the less resistance there'll be, obviously. I don't know. I could bodge in 2 relays back to back. Okay, so it needs to have low contact resistance. These relays are designed to have low contact resistance. Flip it back on eBay. No. I want this for me. And for that cost, it's not worth it. I mean, nah, I'd definitely be... I'd rather spend the $250 than pass it on. You can see how close it is to being fixed. So it may not be the only problem with it. Obviously, I need to clean a couple of other relays, but yeah, true. Sensing is done through the other contacts. The sensing is through contact 12 and 13. So all I really need is a relay which is capable of handling the current reliably. And yes, if I use the high quality relay for 12 and 13, that certainly is a possibility, isn't it? There's a 12-up version, is there? That's a consideration. I could always modify it for that. That wouldn't be hard to do. Yeah, cheaper. Not by much, though. 12-up versions, $120 each. And I have to bodge it. Shipping will be probably free with that cost, though. Sort of half the price. I could buy 2 relays for that. But then I have to bodge it in. Oh, then I also got a slightly different code. It says Y4. What's the difference between Y4 and Z4? Or was that the coil, wasn't it? And it's got version 185. I don't know, I might have to research that some more, see how compatible it is, but it might be an option. Yeah. So what I basically need is a chunky relay to handle the current and a decent high quality contact relay which also handle a bit of current. I'm not quite sure how much current it's got to handle through that sense circuit. I should figure that out actually. And then see that one. So using 2 relays is an option to budget, but I'd rather keep it original if I can. Unless, of course, the original is not up to standard, which is looking likely actually. Yeah. Yeah, Dan, I'm still alive. Although I'm thinking about winding it up now. Because I've got to a point where I can't do much more on this thing until I make a decision about how I'm going to actually progress. I've been procrastinating a lot all week, so it's fine. I only did 8 videos this week. Only 8 videos this week. Actually, I think I did more than that. No, I've done 10 videos this week. Done 10. Yeah. Past your bedtime? Yes, it is. I'm surprised you're still up. Anyway. Yeah. Okay. Yeah. I need to look into this relay situation and figure out what to do with this. Then I can, once I've made a decision about whether I'm going to spend a lot of money or a fair amount of money, or if I'm going to bodge in something. Actually jealous? Jealous of what? Is it this stunning beard? Big Clive-esque? No, it's not that stunning really. Maybe it's the bald spot. Actually, I think your beard's probably better than mine, is it? I don't know. I don't know. I don't know what your face is like, but I've heard you comment about you having a beard, so it's probably better than mine. Anyway. Yeah, only 10. Yes, it's been a lot of it's a lot of work. I did 7 videos in one day. No, sorry, in 2 days. Over a period of 2 days, I recorded 7 videos and edited 8 videos in a period of 2 days. So yeah, that thing is, after I did that, I was pretty knackered. I didn't do much. The day after that, I had a migraine, so I didn't get anything done that day. And then the day after that, I was sort of still didn't feel right still. Still had a bit of a headache hanging around. It wasn't completely gone. So I think I edited 1 video that day. Next day I recorded 1 video, edited 2 videos, something like that as well. So more of an evil goatee, yeah. Anyway, okay, so I think I'm going to wrap the stream up, and I'm going to go and have some lunch, sit down, have a coffee, and decide what I'm going to do about this relay situation, and find out if I need to budget or spend a bit of money. I think I'm going to sit down and try and repair that existing relay and to see how it comes out. If I use it carefully, it might be right. I might put myself a note on the front saying, don't change ranges on in operate mode, something like that, to remind myself not to do it. Probably kind of lower currents, but the higher currents, bad news. Yeah, I think that's what I need to do. That's my plan. 38 centimeters. Wow. Anyway, okay, I'm going to wrap this up. Phone's getting a bit sore too. I've been streaming for quite a while now. 6 hours, is it? Yeah, 6 hours. Anyway, alright, thanks everyone dropping by. I may or may not stream next week. We'll see how it's going. If I've got the rest of the parts of the IT28, I might stream doing that, but finishing it off and doing that final calibration. Who knows? We'll see what we can do. I've got a few things to work on probably, but we'll see. So watch out for the notifications. See if I do one next week as well. If I've got enough to do, maybe will. So thanks everyone for dropping by. Don't forget there's a thumbs up before we leave. And I'll catch you next time.